Hello students, I welcome you all to your very own IGCSE Maths channel. My name is Pankaj, and students, in our today's interaction, we are going to start with the Pure Math 1 paper, the AS Pure Math 1 paper from the Feb-Mar series from the year 2021, and this is from Zone 12. So students, let's begin. So you can see the very first question over here belongs to the chapter series, right? Find the first three terms in the expansion in ascending powers of x of 1 plus x to the power 5. Now, students, you want to understand that this question that you have here demands the expansion of 1 plus x to the power 5. So, to solve this particular question, you first of all need to know the basic expansion of a plus b whole to the power n, right? A plus b whole to the power n. So a plus b whole to the power n is given by, so you have nc0, then a raised to n, b raised to 0, then plus nc1, a raised to n minus 1. So the power descends by 1. For the first term, which is a, the power descends by 1. Multiplied with b raised to 1. Now, if you observe, the power of b is ascending, right? Then plus nc2, a raised to n minus 2 b square. So again, if you observe, for the next term, the power is again descending by 1. If you want to write one more term, let's say nc3, a raised to n minus 3 times b cube, and plus the terms will keep on coming like this. Now, if you have read the question demands only the first three terms in the expansion, right? Not more than three terms are needed. That means I will just need the first term, the second term, and the third term, right? Students, I just need the first three terms. Now, in my question, if I compare 1 plus x to the power 5 with a plus b raised to n, so can you figure out what's the value of a? So a is 1. What about the value of b? The value of b is x. And students, the value of n is 5, right? The value of n is 5. So I just want to plug these values of a, b, and n into the expansion, and that too only in the first three terms, because the question demands only the first three terms. So therefore, I can say 1 plus x whole to the power 5. 1 plus x whole to the power 5 becomes equal to, so the value of n is how much? The value of n is 5. So I write here 5c0 a. So the first term is a, that is 1 to the power n, which is 5. Then you have b. So b is what? It is x. So x raised to 0, right? So x raised to 0 it is. And then plus nc1. So I write plus 5c1 a. So a is again what here? 1 raised to n minus 1. So n is 5. You do 5 minus 1, you get 4. 1 raised to 4. So it's simply descending the power by 1. So it is power 5, then power 4. The next term will have power 3, isn't it? Multiplied with b to the power 1. So what's b? B is x to the power 1 plus 5c2, and then 1 to power what? The power of 1 is going to be 3 now, right, students? So 1 raised to 3 and x raised to 2. Now, I'm not going to go any further of this term because the question says only the first three terms are needed. So I can say here, this is going to be equal to, so 5c0. So students, you need to know nc0 is 1, nc1 is going to be n. So these few concepts from the permutation combination chapter need to be very well remembered. If not, you can simply make use of the calculator and get the answer. So in your calculator, you have this key of NCR. You can make use of that key and get your answer. So I know that 5c0 is going to be 1. 1 raised to 5 is also going to be 1. X raised to 0 is also going to be 1. That means this first term that I have, students, my first term, this first term is simply going to become 1, right? So I'll be writing here 1. Then I know that 5c1, students, nc1, I have written the value as n. So 5c1, it is going to be 5 multiplied with 1 raised to 4. That's again going to be 1 multiplied with x raised to 1. That's going to be x. So that's 5 times x. Now, the value for 5c2. So if you remember, NCR is n factorial divided by r factorial n minus r factorial. You can make use of the formula, or you can straight away make use of the calculator and get the answer for 5C2. Now I know that the answer for 5C2 is going to be 10. You can cross check it. So it's 5 factorial divided by 2 factorial, 5 minus 2, that's 3 factorial. So I can descend 5 factorial as 5 into 4 into 3 factorial divided by 2 factorial is 2 times 1 multiplied with 3 factorial. You can simply cancel the 3 factorial, the 2 and the 5, 2 and the 4 cancels, it's 2, and 5 times 2 is going to be 10, right? So that's how I can say that the value for 5C2 is going to be 10. So I write here plus 10 multiplied with 1 cube, that's going to be simply 1 multiplied with x square. So that's 10x square. So you can easily understand that the expansion of 1 plus x to the power 5, 1 plus x to the power 5 is coming 1 plus 5x plus 10x square, right students? So you do this and you easily fetch 1 mark for this. So of course there is no need to write the expansion formula. I gave you the expansion formula just for your information. Okay, so you need not use the formula there. You cannot write the formula. Simply you can take the values and plug them into the formula if you're well aware of it. So I've got 1 plus x to the power 5 as 1 plus 5x plus 10x squared. So that's a 1 mark question. You have fetched 1 mark for this. You can now proceed to the next part of the question, which says find the first 3 terms in the expansion and again in the ascending powers of x for 1 minus 2x whole to the power 6. So again, if I compare it with a plus b raised to n, students, if I compare it with a plus b raised to n, what can you say the value of a is? So I can again understand that the value of a is 1, right? Now be very careful, students. Can you tell me the value of b? So the value of b is going to be minus 2x, right? A plus b. So here it is 1 minus 2x. So the value of b is going to be minus 2x. And what about the value of n? So the value of n is going to be 6. I write here 6. So again, I'm needing only first 3 terms, right? I need only first 3 terms. So I know I can write this as now 1 minus 2x whole to the power 6 is equal to. So you very well know the formula. It's nc0 a raised to n b raised to 0. So n is 6. So I write here 6c0. A is 1 raised to n, which is 6. B, which is minus 2x raised to 0. That's my first term. The second term is going to be nc1. So I write 6c1. Then you have a raised to n minus 1. So you get 1 raised to 6 minus 1. That's 5. And you'll have the term of b as b raised to 1. So I write minus 2x to the power 1. So the power of b will keep on ascending and the power of a will keep on descending. That's your second term. And now if you take the third term, it's going to be 6c3, not 6c3, sorry for that. So it's going to be 6c2, 1 raised to 4 minus 2x raised to what, students? So minus 2x raised to 2, right? So I just need the first 3 terms. So this is what the expansion will have. Now you very well know that 6c0 is going to be 1, 1 raised to 6 is also going to be 1, and minus 2x raised to 0 is also going to be 1. So the first term is simply going to be 1. Now the second term is 6c1. So I write a plus sign here. Then 6c1 is going to be 6 multiplied with 1 raised to 5 is going to be 1 multiplied with 6. You still get 6 multiplied with minus 2x, right, students? Minus 2x raised to 1 is going to be minus 2x. Then I need to get the value of 6c2. So I can make use of the calculator, isn't it? I can make use of the calculator and get the answer of 6c2, or I have already told you how to solve NCR. You can use that and get your answer. But since you're allowed to make use of the calculator, you will be using the calculator in your exams as well. So students, you can press the key 6, then press the key of shift, and then the division sign. So division sign contains NCR written about it, about it. So you can have NCR. So shift and the division sign. So a C will come or pop up on your screen, and then you want 6C2. So just press 2. So your screen will now see 6C2. press the equal to sign. That gives you the answer 15. So I'm going to write here plus 15. Now again, 1 to the power 4 is going to be 1. No need to write it. And now minus 2x the whole square. Students, the square of a negative term is going to be positive, and then 2 is there. Its square is going to be 4 and then x square. So I simply get 15 multiplied with 4x square. So on simplification, this should give me 1 minus 12x plus 60x square. So that's the expansion of what? 1 minus 2x to the power 6 with the first three terms. Students, we have deliberately written only the first three terms of the expansion. Otherwise, if you take 1 minus 2x to the power 6, students, 1 minus 2x to the power 6 will give us 7 terms in the expansion. Similarly, if you have this 1 plus x to the power 5, this when expanded will give you 6 terms in the expansion. But since the question demands only the first three terms, I have kept my formula up to the first three terms. You getting that? We will not extend or will not go beyond the third term. So I've got the answers for 1 plus x to the power 5, that has fetched me 1 mark, and the expansion of 1 minus 2x to the power 6, that has fetched me another 2 marks. Students, now look at the next question, the next part of the question. The sub question says, hence find the coefficient of x square in the expansion of 1 plus x to the power 5 multiplied with 1 minus 2x to the power 6. Now look at the question. Haven't you got the expansion of 1 plus x to the power 5? Right, students? So I know that 1 plus x to the power 5, the expansion has come 1 plus 5x plus 10x square. So I write here 1 plus 5x plus 10x square. And students, the expansion of 1 minus 2x to the power 6. So 1 minus 2x to the power 6. The expansion has come 1 minus 12x plus 60x square. Now, of course, if I want to write one more term ahead of it, the term would be plus something, some coefficient, and x cube. This will be minus some coefficient and x cube. So I don't need this term of x cube, right, students? Because the sub question C says you want to find the coefficient of x square. So you need to just get the term of x square. You don't want to go beyond the term of x square. That means the first three terms in both the expansions are more than enough to get the coefficient of x square. So I'm simply now going to multiply these two terms. So 1 plus x to the power 5 multiplied with 1 minus 2x to the power 6, you get 1 plus 5x plus 10x square. That's the expansion of the first term, 1 plus x to the power 5, containing only the first three terms. And then I have 1 minus 12x plus 60x square. So I'm going to open the bracket, students. So I'm going to open the bracket. So I know that the first term 1 multiplies with every single term that is present over here. It multiplies with 1, it multiplies with minus 12x, and it multiplies with 60x square. So of these three multiplications, where have you got the term of x square? See, I need the coefficient of x square. So I'll be more focused on getting only the terms of x square. I'm not interested what other terms are going to multiply and come. So let's focus on only the multiplications which can give us x square. So I can see that these two multiplications are not needed. Right, students? I don't need these two multiplications. So 1 multiplies with 60x square. So that should give me 60x square. Now let's take the second term, students. Let's take the second term. So 5x is going to multiply with 1. Not needed, right? 5x into 1, you simply going to get 5x. I don't need that term. Now 5x multiplies with minus 12x. 5x multiplies with minus 12x. What are you going to get? So 5x multiplied with minus 12x, it is going to be minus 60x square. Right, students? So I write here minus 60x square. And the second term f5x is going to multiply with 60x square. So when x multiplies with x square, it is going to be x cube. So again, I'm not interested in this term. So let's forget about this term as well. Now let's take the next term. So 5x has multiplied with minus 12x. You have got the term as minus 60x square. And finally, I'm going to multiply the 10x square with the 1. So I get plus 10x square, right, students? Plus 10x square. No need to multiply x square with x because it will give you x cube. No need to multiply x square with the last 60x square. Again, it is going to give you x is to 4. These terms are not needed, right? So I need only terms which can give me x square. So I have got three different terms: 60x square, minus 60x square, and plus 10x square. You can easily now guess that the plus 60x square and the minus 60x square will get cancelled, and you are left only with what? You're left with only plus 10x square. That means, students, what will be the coefficient of x square? It's going to be just 10. That's your answer. Coefficient of x square is 10. So for this third part, you have scored another 2 marks. So in all, students, for the entire question 1, we have fetched 5 marks. Wasn't it an easy question, right? So let's move on to the next question, students. Let's go to the second question now. So the second question says, by using a suitable substitution, solve the equation. So students, you can observe the equation has 2x minus 3 the whole square, minus 4 upon 2x minus 3 the whole square again, minus 3 equal to 0. So it is very clearly understood that my substitution is going to be 2x minus 3, right? Because 2x minus 3 is repeating 2 number of times into the entire equation. So I'm going to use 2x minus 3 as my substitution. So students, I'll write here substitute 2x minus 3, whatever substitution you want, you can make use of it, students. So I'm going to write 2x minus 3. Let's say I write it as m. For some time, I'm going to call 2x minus 3 as m. So if I call the original equation as equation 1, so what does equation 1 become? So equation 1 becomes m square, right? Because you are writing 2x minus 3 as m. So it's m square minus 4 upon, so again 2x minus 3 is taken as what? It is m. So m square minus 3 is equal to 0, right, students? So it's m square minus 4 upon m square minus 3 equal to 0. Now, can I multiply throughout by m square? Because m square is LCM. I can multiply the entire equation throughout by m square. So that should imply, so the first term gets multiplied with m square. You get m square multiplied with m square. It becomes m raised to 4. Then 4 upon m square multiplies with m square. It remains minus 4. And then minus 3m square equal to 0. Now I'm going to rearrange my terms so that the powers are descending. The powers are descending. So I can write this as m raised to 4 minus 3m square minus 4 equal to 0. Now, students, again, what I'm going to do, I'm going to substitute m square. Let's substitute m square as u. Let's substitute m square as u again for some time. So the first term was m raised to 4. So it's like m square multiplied with m square. So you get u square minus 3u minus 4 equal to 0. Now you can clearly understand that this is a quadratic equation. U square minus 3u minus 4 equal to 0 is a quadratic equation. Minus 4, the last term, which is minus 4, can have the factors as minus 4 multiplied with plus 1, right, students? Minus 4 multiplied with plus 1. And what is minus 4 and plus 1? It's simply minus 3, which is the middle term. So your factors for minus 4 are minus 4 and plus 1. That means you will get the factors as what? So u square minus 3u minus 4. The factors are going to be u minus 3 multiplied with u plus 1 equal to 0. Right, students? U minus 4 multiplied with u plus 1 is equal to 0. But what was u? If you recall, the value of u was m square. So I'm going to replace the value of u as m square. So I can say, therefore, m square minus 4 multiplied with m square plus 1 becomes equal to 0. That implies that either m square minus 4 is 0, or you can say m square plus 1 equal to 0. That should give me m square is equal to 4 or m square becomes equal to -1. Now, you very well know that square of a number, m square, when you say it is square of m. So square of a number can never ever be negative. That means, students, this m square is equal to -1 needs to be discarded. The square of a number cannot become negative. So m square equal to -1 is not going to happen. So m square equal to 4 is the only correct answer, right? So m square is going to be equal to 4. Now, if m square is equal to 4, I can proceed further and write m is equal to what? So if m square is 4, m becomes equal to plus and minus 2, right? M square is 4, then m is plus and minus 2. But now you want to really remember that you are not solving for m, you are solving for x. Do you recall your question, students? The question says, by using a suitable substitution, solve the equation. The equation, if you observe, it is 2x minus 3 the whole square minus 4 upon 2x minus 3 the whole square minus 3 equal to 0. So you are solving for x. Now, if you recall back again, 2x minus 3 was taken as m. So I know what's the value of m now. It is 2x minus 3. So I'm going to replace m with 2x minus 3. So I write here, but m is 2x minus 3. So when m is plus 2, m is plus 2, I can write 2x minus 3 is going to be plus 2. So 2x becomes equal to, so minus 3 shifts the side, right? So minus 3 plus 2 I get. So that's plus 5 minus 3 plus 2. That gives you plus 5. So x would come out to be 5 upon 2. Similarly, when m is minus 2. So I can say, I'll write here, or m is equal to minus 2. So m I know is 2x minus 3. This is equal to minus 2. So 2x becomes equal to what? So again, minus 3 will switch its place. It will transfer on the other side. So minus 3 becomes plus 3 minus 2. That's 1. So 2x is 1. X becomes equal to 1 upon 2. So I've got a value of x as 5 upon 2, or the value of x is 1 upon 2. So these are the values of x. So I can call them as my solution. So x is equal to 5 upon 2 and x is equal to 1 upon 2. That's your answer, students. So that's the solution for question number 2. Very simple question, right? And you have fetched 4 marks for this question. Let's proceed further. Let's go to question number 3. So now this question number 3 is from trigonometry, right? So you need to clearly understand what the question is. Again, it's asked to find or solve the equation, right? Now, when you say solve the equation, so basically is asking you the value of the variable. And who's the variable here? So it's tan theta plus 2 sine theta upon tan theta minus 2 sine theta. It is clearly understood that theta is your variable. Have you seen that the range of theta is also given from 0 degrees to 180 degrees? That means here theta is your variable, right, students? So let's see how the question needs to be solved. So remember that theta is from 0 to 180. That means I can say that theta lies in the first or the second quadrant. You getting that? So if I take the x and the y axis like this, so theta is from 0 to 180. So this is 0 degrees and this is 180 degrees. So this is the first quadrant and this is the second quadrant. So the question is for 4 marks. Let's write all the steps very properly. So I have tan theta plus 2 sine theta whole divided by, you have tan theta minus of 2 sine theta, it is equal to 3, right, students? So I can now cross multiply. I'm going to cross multiply this denominator on the other side here where 3 is present, and I want to simplify the equation. So I should be getting now tan theta plus 2 sine theta is equal to 3 multiplies with what? Tan theta minus 2 sine theta. That's 3 tan theta minus 6 sine theta, right? Now you want to rearrange the terms. So what we'll do is we'll correct all the terms of sine on one side and all the terms of tan on one side. So I get 2 sine theta plus 6 sine theta is equal to 3 tan theta minus of tan theta. So that should give me what, students? So 2 sine theta plus 6 sine theta, that gives me 8 sine theta. is equal to, I have 3 tan theta minus tan theta. That should give me 2 tan theta. So of course the 8 and the 2 can be cancelled. So I get 4 sin theta is equal to tan theta. Now what you should be doing is you should write the equation like this: 4 sin theta minus of tan theta is equal to 0. But students, don't you all know that tan theta is sin theta upon cos theta, right? So we are all aware of this. Tan theta is equal to sin theta upon cos theta. So I'm going to write the tan theta as sin upon cos. So I write here 4 sin theta minus tan theta is what? Sin theta upon cos theta is equal to 0. Now, what I'm going to do here is I'm going to take out the sin theta common. Let's bring the sin theta common. So I take out the sin theta outside the bracket. I'm left with 4 minus 1 upon cos theta equal to 0, which I can cross multiply and write sin theta multiplied with. So I'll be getting what, students, here? I get 4 cos theta minus 1, right? 4 cos theta minus 1 divided by cos theta, close the bracket, it is equal to 0. Or I should better write this as, so what, sin upon cos. So this is sin theta, this is cos theta. So I can write sin upon cos, right? So sin theta upon cos theta is tan theta. So tan theta multiplied with what? Multiplied with 4 cos theta minus 1 is equal to 0. So now it is tan theta multiplied with 4 cos theta minus 1 equal to 0. Now you want to understand, this is product of two terms. It's tan theta multiplied with some bracket, isn't it? 4 cos theta minus 1. And the product is coming equal to 0. That means I can say either tan theta should become equal to 0, right, students? Or you can say 4 cos theta minus 1 should become equal to 0. Now, you need to really understand this well. So if tan theta is 0, that means theta would become equal to tan inverse of 0, right, students? So tan goes on the other side, it becomes tan inverse. So tan inverse of 0. So 4 cos theta minus 1 equal to 0 also implies that 4 cos theta becomes equal to 1, which implies cos theta is equal to 1 upon 4, right? I have simplified it in terms of cos. So from here, I can say theta becomes equal to cos inverse of 1 upon 4, right? So theta is tan inverse of 0 or theta is cos inverse of 1 upon 4. So again, students, we are going to take the calculator, and in this we are going to find the values of tan inverse of 0 and cos inverse of 1 upon 4. Now, make sure that your calculator is in the degree mode. The calculator needs to be in the degree mode. So you can check whether that small d is written in the calculator or not, or you can just press shift and setup, and then you have degree mode on option 3. So you can press 3 there, it comes into degree mode. So now I'm going to write tan inverse of 0. So I press shift and the tan button, that will give you tan inverse of 0, close the bracket. The answer comes 0. So theta is equal to 0. Students, tan inverse of, if you try and get pi, tan inverse means if you take tan of pi, so tan of pi is also going to be 0. So it can be, so when you say tan inverse of 0, it can be either 0 or it can be pi also. Okay, so 0, then the next value is pi. Okay, so all multiples of pi, if you have all multiples of pi, so that's pi, 2 pi, 3 pi, 4 pi, 5 pi, all these multiples of pi are going to give you the answer as 0. So tan of 0, tan of pi, tan of 2 pi, tan of 3 pi, and so on. Having this information is very important, students, because sometimes what might happen, the value of theta might be given from 0 to 360, right? So if it is 0 to 360, you need to know for every single value of theta when the tan is going to come 0. So it is 0, pi, and so on. So I can write here n pi. But here I know that theta is restricted between 0 to 180 degrees, if you remember, right? Theta is from 0 to 180 degrees. Look at the question. The question says that theta is lying between 0 to 180 degrees. So I have the value of tan inverse of 0 as 0 or pi. Now, did you see theta lies between 0 and 180, but excluding 0 and 180? 0 and 180 are not the values of theta. So theta cannot become 0 or pi. So I can say here, but theta cannot become 0 or pi. So this is discarded. Now let's come to theta is equal to cos inverse of 1 upon 4. Now, are you aware that cos theta is positive in the first quadrant and negative in the second quadrant? So I know that the theta was lying in the first or the second quadrant. In the first quadrant, cos is positive in the first quadrant, right? And in the second quadrant, cos is negative. But have you seen here the value of cos theta is positive? It's positive, right? Cos theta is positive. So it is a clear indication that theta lies only in the first quadrant. So the calculator is capable to give you the very first angle. You getting that? So if you uh, uh, feed the calculator as cos inverse of 1 upon 4, it will give you the very first acute angle. So I again take the calculator, I press the shift sign and the cos button. So above cos, it is cos inverse. So you get cos inverse and you write 1 divided by 4. Make sure that the calculator is still maintained in the degree mode. So cos inverse of 1 upon 4, the answer comes 75.52248 and so on. So I'm going to restrict myself to 2 decimal places. So it's 75.52, right? So theta is going to be 75.52. Now, why did I get my answer in degrees? Because if you observe the question says theta lies between 0 degree and 180 degree. So the theta itself is given in degrees. If it was given in radians, I would have used the radian mode of the calculator and I've got the value of theta in radians. Now, since the question demands the value of theta in degrees, I'm going to maintain my answer of theta as 75.52 degrees. You got that? So that's your question number 3, students, which has fetched you 4 marks. Let's proceed further. So plenty of space given, right? Now, the fourth question is a very important question, students. You want to really understand the question along with the concept. Now, a line has equation y equal to 3x plus k. Now, it is clearly mentioned that you have a line, and it can be also understood that even if you are given only the equation y equal to 3x plus k, k is a constant, it can be clearly understood that this is a first degree equation, and a first degree equation always represents a line, right? Now, the line has equation y equal to 3x plus k, and a curve has equation y is equal to x square plus kx plus 6. So this is a second degree equation. A second degree equation, students, in general will represent a parabola. So y equal to x square plus kx plus 6. So here it is x square. So the parabola is going to be U-shaped. It's going to be a U-shaped parabola, right? And moreover, you can say it is y equal to x square plus kx plus 6. So I can have the parabola which might look somehow like this. Okay, that's the equation. That's a graph of the parabola. The equation of the parabola is y is equal to x square plus kx plus 6. And there is a line whose equation is y equal to 3x plus k. So, and again, k is a constant. You want to find the set of the values of k for which the line and the curve have 2 distinct points of intersection. So you want to understand the question. 2 distinct points of intersection is what the question is demanding. That means the line and the curve are both intersecting. So I'm going to draw my line like this. Let's say that's a line. So the equation of the line is y is equal to 3x plus k. Now you can observe that the line and the curve are both intersecting at 2 distinct points. I call them as A and B. So I want to find the set of values of k for which the line and the curve are going to have 2 distinct points of intersection, right? So how do I get the points of intersection, students? If I want to find the points of intersection of the line and the curve, how do I get it? I simply solve the 2 equations simultaneously. Can I call my first equation? I'm going to call my first equation as y is equal to 3x plus k. That's my first equation, right? This is equation number 1. and the equation y equal to x square plus kx plus 6 as my second equation. So that's equation number 2. So I have equation 1 and equation 2. I want to solve them simultaneously. Now the problem with the equations is one of the equation is a first degree equation and the other equation is a second degree equation. So I cannot solve them simultaneously. What I need to do is I need to equate the two equations. Okay, so I'm going to equate the two equations. So if I equate the two equations, I can say therefore x square plus kx plus 6 is equal to 3x plus k, right? X square plus kx plus 6 should become equal to 3x plus k. I'm trying to solve the two equations simultaneously. I'm trying to find the coordinates for points A and B. What should be the set of values of k for which the line and the curve might have two distinct points of intersection? So that's very important line, students. You want to remember that now. Okay, so x square plus kx plus 6 equal to 3x plus k. Now when you are going to solve these two equations simultaneously, you have eliminated y, so you are going to solve for x. That means if you solve the equation that is seen on your screen, you will get the x coordinates of the 2 points A and B. You are going to get the x coordinates of the point A and point B. So I can write here x square, then you have plus kx. There is a 3x on the other side, isn't it? You can bring it here. So it becomes minus 3x. So there is kx and then there is minus 3x. So you get plus k minus 3x and then plus 6 minus k is equal to 0. So that's your quadratic equation of x. Solve this quadratic equation of x. You will be getting two values of x, and these two values of x are what? They are the x coordinates of the points of intersection of A and B. Now students, look at this. Since it's a quadratic equation, it is bound to give you two values of x, right? Now these two values need to be different. These two values need to be distinct. The question says that the line and the curve should intersect each other in two distinct points. So when I solve this quadratic equation, I should be getting two different values of x, right? And the values must be real also. Now students, a quadratic equation can give you two distinct real values, two distinct roots, two distinct real roots if b square minus 4ac is greater than 0. You need to remember the concept of the discriminant. If b square minus 4ac is less than 0, then the quadratic equation will give us roots which are complex conjugates, or we simply say the roots are imaginary. If b square minus 4ac becomes equal to 0, then the roots are identical. The two values of x are going to be same. And when b square minus 4ac is greater than 0, then you get two distinct real roots. That is what my requirement is, isn't it? After solving the equation, the quadratic equation that I've got, I should be getting two different values of x. And that can happen only if b square minus 4ac becomes greater than 0. So I have this equation x square plus k minus 3x plus 6 minus k equal to 0. I'm going to compare this equation. Let's compare this. Compare with ax square plus bx plus c equal to 0, right? So I will write here for two distinct roots b square minus 4ac. b square minus 4ac must be greater than 0. So I'm going to compare my given quadratic equation with ax square plus bx plus c equal to 0. So that gives me the value of a as 1, the value of b as k minus 3, and the value of c as 6 minus k, right? So let's take b square minus 4ac greater than 0. So I can write therefore b square minus 4ac is greater than 0. So b is what? B is k minus 3. So I write k minus 3 the whole square minus 4. A is 1. C is 6 minus k. This should be greater than 0. Let's simplify this. So I get k square. I'm going to expand k minus 3 the whole square. It's like a minus b the whole square. A square minus 2ab plus b square. So I get k square minus 6k plus 9, right? Then I have minus 4 multiplies with 6 minus k. So I should be getting minus of 24 and plus 4k. This is greater than 0. So I get k square. Then you have minus 6k and plus 4k. So that's minus 2k and then plus 9 and minus 24. So that should give you minus 15, right? Plus 10 and minus 24. You can make use of calculator if you have to, students. So minus of 15 greater than 0. So this is a quadratic equation of k, right, students? You need to remember the entire flow of the question. I had a curve, I had a line, they are both intersecting, isn't it? It is asked to me that they should intersect. For what value of k they will have two distinct points of intersection. So this is what my question was. So now k square minus 2k minus 15 should be greater than 0. That's a quadratic equation, right? So minus 15 will have factors minus 5 multiplied with plus 3, right? Minus 5 multiplied with plus 3, and minus 5 and plus 3, if you do, you get minus 2. So you can easily understand minus 2k is the middle term, minus 2, right? And the factors of minus 15 are minus 5 and plus 3. So I'm going to write k square minus 2k minus 15 as what? So it's going to be k minus 5 multiplied with k plus 3 is greater than 0. Now comes the real challenge to decide the values of k. Now try and understand, students. K minus 5 multiplied with k plus 3. So these are two terms. They are multiplied and the answer is greater than 0, right? The answer is greater than 0. That means multiplication of two terms is giving me a positive answer. Greater than 0 means what, students? Greater than 0 means the answer needs to be positive. So k minus 5 multiplied with k plus 3, the answer needs to come positive. And that can happen only when k minus 5 is greater than 0 and k plus 3 is greater than 0, right? So if the product of the two terms is greater than 0, that means the two terms need to be greater than 0, or both the terms need to be positive, right? Or I should have k minus 5 less than 0 and k plus 3 also less than 0. You need to really understand this well. The product of the two terms can be positive, can be greater than 0 if both the terms are greater than 0 or both the terms are less than 0. A negative number multiplied with a negative number gives a positive answer, right? A positive number multiplied with a positive number will definitely give us a positive answer. So k minus 5 is greater than 0 and at the same time k plus 3 should also be greater than 0. Only then the product of these two terms is going to be greater than 0. So I can have, so k minus 5 greater than 0, that gives me k is greater than 5 and at the same time k should be greater than minus 3. So students, if I draw a number line like this, let's draw a number line. Okay, so I'll have this as minus 3, let's say. Then I have minus 2, then I have minus 1, then 0, then 1, then 2, then 3, then 4, then 5, right? Like this, the values will keep on coming, isn't it? On a number line, I can plot all these points. So k needs to be greater than 5. So if I want k to be greater than 5, these are the values which will be k greater than 5, right? This is k greater than 5. And at the same time, k should be greater than minus 3 also. So k should be greater than minus 3 will be all these values, right? All these values, including 5 also, including the values which are ahead of 5 also. This is k greater than minus 3. So now you want to really understand this well, that k at the same time needs to be greater than minus 3 and greater than 5 also. Now, all these values that you have over here, they are greater than minus 3, but they are not greater than 5. So these values need to be discarded. For instance, 4 is greater than minus 3, but it is not greater than 5. So the value 4, the value of k cannot become 4. The 4 value needs to be discarded. So if I'm saying that k is greater than 5 and k is greater than minus 3, only one condition will be true from here, and that condition is k is greater than 5. Therefore, k is greater than 5. So I've got k greater than 5 from the first case, right? When both the values were positive. So this I can call it as case 1. I would now discuss case 2. So this is case 2 when both the values of k are when both the values of k minus 5 and k plus 3 are less than 0. They're both negative. That means I can write over here k should be less than 5, and at the same time k should be less than minus 3. So again, if I want to make a number line like this, so I'll be having minus 3 over here. That's minus 3. All values which are less than minus 3, students, less than minus 3, isn't it? So all these values over here, all these values, are they all less, right? They are all less than minus 3. And then I have the other value as 5. So let's say this is 5. So I need to take all the values which are less than 5, all the values which are less than 5. So I'll take all these values which are less than 5. So when I say less than 5, they include values which is less than minus 3 also, right? So this is k less than 5. Now, in between whatever values you have here, between minus 3 and 5, let's say you take 0. 0 is less than 5, but 0 is not less than minus 3. So 0 cannot become the value of k. K needs to be less than 5, and it also needs to be less than minus 3. So from here you can conclude that k should be less than minus 3, right, students? Isn't it? So collectively, what should be the value of k? So k should be less than minus 3, isn't it? So therefore, I can finally say k should be less than minus 3, right? Or k should be greater than 5, right? So whenever the value of k is less than minus 3 or the value of k is greater than 5, you will get two distinct roots of x square plus k minus 3x plus 6 minus k equal to 0. You'll get two different values of x. If you want, you can check. You check for any value of x, any value of x which is greater than, so you will take first of all k greater than 5, right? So take any value of k which is greater than 5. Let's say you might take the value of k as 7. You can take the value of k as 7, put it in the equation, this equation that you have, this quadratic equation. You plug the value of k as 7, solve the quadratic equation, you will definitely get two different values of x. Similarly, even if you take any value of k as minus 3, k as less than minus 3, of course, less than minus 3, which is maybe you can take minus 4 or minus 5 or minus 6, anything like that. Okay, and you again plug back to the quadratic equation, you will again get two distinct values of x, and these values will be real as well. Now you are not required to find these values of x, right, students? You just wanted to find a set of values of k. For what values of k? The line and the curve will have two distinct points of intersection. That is what the question was. So k should be less than minus 3 or k should be greater than 5. For these two values of k, or for this set of values of k, there will be a quadratic equation which will give you two distinct values of x, and that's why you get two distinct points of intersection. That was a question number 4, students, which will fetch you another 5 marks, right? So conceptual understanding is very important while solving the questions. Students, let's go to the next question, the question number 5. Now, this is an interesting question, students. In question 5, what does it say? What's the question about? The question says, in the diagram, the graph of y equal to f of x is shown with solid lines. So it is this one. This is y equal to f of x, solid lines. And this curve, the graph shown with broken lines, is the transformation of y equal to f of x, right? The graph shown with the broken lines is the transformation of y equal to f of x. So this is the transformation, right? That's a transformation, and that's your original graph, right? So there is an original graph, there is a transformation. What you want to do, describe fully the two single transformations of y equal to f of x that have been combined to give the resulting transformation. And the question is for 4 marks. Students, you really want to understand this question because I have seen people discussing this question based on the marking scheme. Okay, so you really want to understand how to arrive at that particular result. So I'm going to use a technique of getting the answer. Okay, so observe carefully what is my procedure. So what I'm going to do here is I'm going to call, let's say, this y equal to f of x, the solid lines. You can name it. Okay, let's call this as point A and point B. So you have line AB, and this line AB is getting transformed into a dotted line, into a broken line. So I can call this point as A prime and this point as B prime. I'm going to get the equations of the two lines AB and A prime B prime. Okay. So if you want, you can name this point as C over here. This point is C, and then this point would become C prime. You can get the equation of AC also. AC and A prime C prime does not matter, students. Okay. It does not matter whose equation you are going to get. You can get the equation of AC, A prime C prime, or you can get the equation of AB and A prime B prime. And from there, you can use the concepts of transformations to understand what two transformations are utilized over here, so that the graph of y equal to f of x gets transformed into the broken lines. Okay, let's understand. So students, I'm going to take, maybe let's say we take line AC. Let's take line AC. Okay, and A prime and C prime. Okay, now you can clearly understand that this line AC, if I draw, maybe I draw the line AC over here. I'm going to draw this line AC. Okay, so I've drawn the line AC. Got it? So I take this AC, I shift it here. Okay, now to make this line AC look like A prime C prime, see what I need to do. I will need to stretch it in the y direction, right? I will need to stretch this line in the y direction like this, right, students? Isn't it? So stretching is involved, isn't it? Stretching is involved. Same is with the line AB also. Line AB will also will need to stretch the line AB also to A prime B prime. So stretching is definitely there, right? And then there is transformation. There is a linear transformation. There might be a transformation in the x direction, transformation in the y direction. I do not know that. Okay, so let's see how this can be solved. So I'm going to find the equation of line AC and equation of line A prime and C prime, students. Okay, equation of line AC and equation of line A prime C prime, and then I will judge how line AC can be transformed into the line A prime C prime. So let's begin. So I'm writing here equation of line AC. Okay, now for that I will need the coordinates of point A and C. So you can observe that point A will have coordinates. So you can see that it is x coordinate 0.5, right? And the y coordinate is 1. So A has coordinate 0.5, which is 1 upon 2. X coordinate is 1 upon 2, and the y coordinate is 1. And the point C will have the x coordinate as 0, and the y coordinate is 2. Right, students? So let's get the equation of line AC. So we know this form y minus y1 upon x minus x1 is equal to y2 minus y1 divided by x2 minus x1. This is called as a two-point form of the equation of line. You are well aware of it, right? So I can call any point as x1 y1 and any point as x2 y2. It does not matter really, students. So I write y minus, so y1 is 2. Let's say y1 is 2 divided by x minus x1 is 0. So I write here 0. That is equal to, I do y2 minus y1. So I write 1 minus 2. 1 minus 2 divided by, I have 1 upon 2 minus 0. So that gives me y minus 2 upon x is equal to, so that's 1 minus 2, which will give me minus 1 upon 2, which simply gives us minus 2. So this is equal to minus 2. So I get y minus 2 is equal to minus 2x, right, students? And that gives me y is equal to minus 2x and plus 2. So that's the equation of line AC, right, students? Equation of line AC. Now, let's try and get the equation of line A prime C prime, okay? For that, I'll need the coordinates of A prime and C prime. So you can easily observe that the coordinates of A prime, the x coordinate is 4.5. So I can call the x coordinate of A prime as 9 upon 2, comma, the y coordinate is going to be what? It is going to be 3, right? The y coordinate is 3. Be very careful with the coordinates. So 9 upon 2, comma 3. And for C prime, it is going to be what? So x coordinate is 4 and the y coordinate is 6. So 4, comma 6. Let's quickly get the equation of line A prime, C prime. So equation of line A prime, C prime. So again, students, I'm going to make use of the same concept, y minus y1 divided by x minus x1. So I can write y minus 6 upon x minus 4 is equal to, so that's now y2 minus y1, so 3 minus 6, 3 minus 6 divided by x2 minus x1, so 9 upon 2 minus 4, 9 upon 2 minus 4, right? So that gives you 3 minus 6, which is minus 3, right? 3 minus 6, it is minus 3 divided by 9 upon 2 minus 4. So 9 minus 8, 9 minus 8, that's 1, 1 upon 2. So you get 1 upon 2. So that comes out to be minus 6. That comes out to be minus 6. So this is equal to minus 6, right? So y minus 6 upon x minus 4 is equal to minus 6. So I'm going to simplify this. So y minus 6 is equal to minus 6 multiplies with x minus 4. That gives you y minus 6 is equal to minus 6x plus 24. So y becomes equal to minus 6x and what? So 24 plus 6, that becomes 30. Right, students? So that's the equation of line A prime, C prime. So I have the two equations now with me. One of them is the equation of what line? Equation of line AC. The other one is the equation of line A prime, C prime, right? Now, AC is getting transformed into A prime, C prime. You want to understand what this transformation is. Students, I'm going to call the equation of line AC as equation 1. So let's call equation of line AC as equation 1 and the equation of line A prime, C prime as equation 2. I'm going to transform equation 1 into equation 2. Now, you have already realized that the lines AB, AC are getting stretched. So there must be some stretching factor, some scale factor, right? By that amount, the lines are getting stretched. Moreover, the entire graph is shifted, right? The entire line AB, AC is shifted to a different place. Now, if you have observed the positions of point A and A prime, can you say that A and A prime has shifted by 4 units? Look at the x coordinate. Look at the x coordinate of A. Look at the x coordinate of A prime. So it's 1 upon 2, which is 0.5. Then there is 9 upon 2, which is 4.5. So you can understand that 0.5 to 4.5, there is a horizontal shift of 4 units, right? The vertical displacement is, of course, there. It is of 2 units, but then the vertical displacement for all the points is not same. But look at the horizontal displacement, students. If you take a look at the point B, it is at x coordinate 2. Look at B prime, it is at x coordinate 6. That means again there is a shift of 4 units. Likewise, if you take a look at point C and C prime, so C was on the y-axis, so the x coordinate is 0, and for C prime the x coordinate is 4. That means there is again a shift of 4 units. Right, students? That means you can see that the entire graph AB and AC is shifted by 4 units. So, and the shift is in the right direction. Right, students? The shift is in the right direction. So you must be recalling these transformations. So the transformations, if the entire graph is shifted to the right, the entire graph is shifting to the right. So x changes to x minus a. If the graph is shifted by a units to the right, so I can have y is equal to f of x, y is equal to f of x as my original equation, if the graph of f of x is going to shift in the right direction by a units, then x will get replaced by x minus a. So y becomes equal to f of x minus a. So I can write here the entire graph shifts right by 4 units, right? And if there is a stretching that is happening, if the stretching is in the vertical direction, now there are again stretching happening in the vertical direction, or there is a stretching happening in the horizontal direction. Whenever it is happening in the vertical direction, you have a times of f of x. So y is equal to a times of f of x. So there is a stretch happening by the stretch of a units. The function f of x will get stretched by a units in the vertical direction. So I can say here stretching by scale factor of a in the vertical direction, in the vertical direction. So now students, if you observe in our question, there is definitely a horizontal shift of 4 units, horizontal shift in the right direction by 4 units. So x needs to get replaced, needs to get replaced by x minus 4. So go to equation 1. So from equation 1, I can write y is equal to what? Y is equal to, I have minus 2 times of you have x. So x is getting replaced with x minus 4 and plus 2. Let's simplify this. So I get minus 2x plus 8 and plus 2. That gives me what, students? It gives me minus 2x plus 10, right? Minus 2x plus 10. Now look at equation 3. It is y equal to minus 6x plus 30. Look at equation 1 after transformation in the horizontal direction by 4 units right, by 4 units, it is minus 2x plus 10. Now can you not think that if you multiply minus 2x plus 10 by 3, so y is equal to 3 times of minus 2x plus 10, won't you be getting minus 6x plus 30, right? Which is the equation of line a prime c prime, y equal to minus 6x plus 30. So this is the equation of a prime c prime, right, students? That means the original graph is getting stretched by 3 units. See, the scale factor is 3 here, and the original graph is also shifting only in the right direction, not in the y direction, students. The graph is not shifting in the y direction. If it was shifted in the y direction, then your original graph of y equal to f of x, will become like this: y is equal to f of x plus a. So this will shift the graph in the y direction. So plus a units up, right? If it is f of x minus a, then a units down, isn't it? If you replace x with x minus a, so it will shift in the right direction by a units. If you replace x with x plus a, then it shifts left by a units. So you can understand here that the entire graph, now I wanted only 2 transformations. See, the question says by 2 single transformations, the curve y equal to f of x, which is made by solid lines, will transform into the curve shown by the broken lines. So I can say the transformation is what? So there is a stretching by a scale factor of 3 in the vertical direction, right? Y equal to 3 times of f of x. So stretching in y direction by a scale factor of 3. That's one transformation. And the second transformation is shifting in horizontal right direction by 4 units. by 4 units. These are your two transformations, students. Stretching in the y direction by a scale factor of 3 and shifting in the horizontal right direction by 4 units. Now, in this entire process, the second question is already solved. State in terms of y, f, and x the equation of the graph shown with the broken lines. Equation of the graph shown in broken lines is this, isn't it? So y is equal to minus 6x plus 30. You cannot see it. Let's use a different color. So I can have y equal to minus x plus 30. Even if you do this with line AB and A prime, B prime, you will still end up with the exact same equation. So I can write the equation of the broken line as what? So I had original equation as what? Y is equal to f of x. That's the equation of line which is shown with a continuous graph, right? So equation of solid lines, equation of solid lines. So what has happened to the equation of the broken lines? So there is a stretch by 3 units. So 3 times of f of x. Stretching has happened. Stretching. And there is a horizontal shift, right? There is a horizontal shift by 4 units. So f of x minus 4. So this is horizontal shift. Horizontal shift. So that should be your equation of the line of the broken line. So I could do 3 times of f of x minus 4. So here also I could have written my answer as stretch by a scale factor of 3 and shifting in the horizontal right direction. So it is denoted by 4 and 0, like this. Your marking scheme will have the answer given in this format, 4 and 0. So now you have got the equation of the broken lines with y, f, and x. So y equal to 3 times of f of x minus 4. So that's for 2 marks. So you must have observed how this question needs to be tackled, right? So there is a stretching by 3 units, right? Stretching by 3 units, and there is a horizontal shift of 4 units, right? So you could have come to this conclusion directly also if you solve a few questions based on this type. You should be able to guess this. You should be able to get the answer without solving the entire equation of line AC and equation of line A prime C prime, or maybe equation of line AB and equation of line A prime B prime, right? But then solving this will give you a certain affirmation. It will give you a confirmation that yes, whatever I've done is the correct thing, right, students? So now that was question number 5 completely solved. We'll go to question number 6 now. Now, what does the question number 6 say? So there is a curve such that dy upon dx is 6 upon 3x minus 2 the whole cube. So dy upon dx is given. Students, are you aware that the dy upon dx, when you say, what is dy upon dx? So dy upon dx is the slope, or you can say gradient. One and the same things, right? Slope or gradient of the tangent. Gradient of the tangent to the curve, right? It is the slope or the gradient of the tangent to the curve. So dy by dx is the slope of the tangent drawn to the curve. So I have dy upon dx. Now this curve will have some equation. Let the equation of the curve is equation of curve is y is equal to f of x, right? Equation of the curve is y equal to f of x. It will have some equation. Now this curve has a point A whose coordinates are 1, minus 3, and this point A 1, minus 3 lies on the curve. So there is a point A whose coordinates are 1, minus 3, which is lying on the curve. So I do not know what this curve is looking like. I'm just making some random diagram. Okay, so if I draw the y-axis, again students, I'm telling you that I am drawing some random diagram. Okay, so x-axis and y-axis. Okay, and maybe this is the curve, who knows? Okay, this is the curve y is equal to f of x, and there is a point whose coordinates is 1, minus 3. So it might be somewhere maybe here. That's the point A whose coordinates are 1, minus 3. There is a point A whose coordinates are 1, minus 3. It lies on the curve. Now a point is moving along the curve. So there's a point which is moving along the curve, And at A, the y coordinate of the point is increasing at 3 units per second. Now, what is this, students? This is the rate measure. The y coordinate of the point at point A, it is increasing by a rate of 3 units per second. So what is given to you? Students, you are given the rate of change of y coordinate at point A. So it is dy upon dt. Dy upon dt, rate of change of the y coordinate at point A. And that rate of change is given to us as 3 units per second, right? Now look at the first question. What is it asking? Find the rate of increase at A of the x coordinate of the point. So I know for point A, the point is specifically given to you. So for point A, the rate of change of y coordinate is 3 units per second. What is the rate of change of x coordinate? What is dx upon dt? That is what the question is. Okay, now we know that what is dy upon dx? We know dy upon dx is equal to, it is 6 upon 3x minus 2 the whole cube. I write 6 upon 3x minus 2 the whole cube. Now students, I am pretty confident that you are already aware of something called as a composite function, or we can call it as a chain rule. So can I write dy upon dx something like this? It's still dy upon dx, right? And then I can write dy upon dt multiplied with dt upon dx. So I've multiplied with multiplied and divided by dt. It's like this. Okay, so dy upon dt is getting multiplied with dt upon dx. This is chain rule. Okay, students, this is called the chain rule, and this is equal to what? So it was dy upon dx, which is transformed as dy upon dt into dt upon dx. But basically it is dy upon dx only. So it is 6 upon 3x minus 2 the whole cube. Now, don't I know the value of dy upon dt? See, the value of dy upon dt is given to us. It is 3 units per second. I'm interested in the value of dx upon dt. Now, students, remember, there is another rule of inverse functions. Inverse functions. So it basically says that if you have dy upon dx, this can be written as 1 upon dx upon dy. Dy upon dx can be written as 1 upon dx upon dy. So can I now say dy upon dt multiplied with dt by dx is 1 upon dx upon dt? Yeah, students, I can write dt upon dx as 1 upon dx upon dt. This is equal to 6 upon 3x minus 2 the whole cube, which can be further written as dy upon dt is equal to 6 upon 3x minus 2 the whole cube multiplied with dx upon dt. So my point of interest over here is to get the value of dx upon dt. So let's plug all the values that I know. So dx upon dt, I want to find dy upon dt for the point A is given to us. The coordinates of point A is what? The coordinates of point A is 1 comma minus 3, right? The coordinates of point A is 1 comma minus 3. So I write here 1 comma minus 3, and dy upon dt is how much? So dy upon dt is given to us as 3 units per second. So dy upon dt is 3. So I get 3 is equal to 6 divided by, I'll be having 3x minus 2 the whole cube. So 3 multiplied with x is 1 minus 2 the whole cube multiplied with dx upon dt. Right, students? So I get 3 is equal to 6 upon, so that's 3 times 1, that's 3, 3 minus 2, which is 1. 1 the whole cube is still going to be 1 into dx upon dt. So on solving, I will be getting dx upon dt as 3 upon 6, or it is 1 upon 2 units per second. So that's the solution for the first part, A. So it is for 3 marks, right, students? Very simple, right? I've got dx upon dt. So this dx upon dt is with respect to point A. So half units per second with respect to point A. This is only for point A. Getting? This is the rate of change of the x coordinate at point A when the rate of change in the y coordinate was known to us. So that completes my first part of the question, right? Now let's move on to the second part. What does the second part say? Find the equation of the curve. I want to find the equation of the curve. That means I want to find what is y equal to f of x, right? I want to get that equation of the curve. So again, it's very simple, guys. Okay, you want to find the equation of the curve. So let's go to the second part. So I have got the rate of increase at A of the x coordinate of the point. So dx upon dt is done. I want to find the equation of the curve. So I want to find what is y in terms of x. What is y equal to f of x? Now, what is dy upon dx given to us, students? What is dy upon dx? So this question is from the differential equation. So you need to know some concept of differential equations as well. So dy upon dx is equal to what? It is 6 upon 3x minus 2 the whole cube. So I'll write here 6 upon 3x minus 2 the whole cube. Okay. Now, what is this? Dy upon dx is equal to 6 upon 3x minus 2 the whole cube. I'm going to integrate both the sides. But before integration, I'm going to write it like this. Dy is equal to 6 upon 3x minus 2 the whole cube dx. This is what I've written. Okay. So this concept is basically from integration and something called as a differential equation. So dy upon dx was equal to 6 upon 3x minus 2 the whole cube. I have just transferred the dx on the other side and I'm going to integrate both the sides. Students, I'm going to integrate both the sides. So integrating both hand sides. Integrating both hand sides. So if I integrate both the sides, I will be getting integration of dy is equal to integration of, I have 6 upon 3x minus 2 the whole cube and dx. Of course, you need to know the basic rules of integration. Students, what is integration of 1 dx? Integration of 1 dx is basically x plus c, right? What is integration of ax plus b to the power n dx? Students, you need to be very careful with all the formulas of integration that you have learned. Okay, of course the formula booklet is available, but if you have these formulas on the tip of your tongue, it is really going to be very helpful while solving certain questions. So integration of ax plus b raised to n, it simply comes out to be ax plus b raised to n plus 1 upon n plus 1. So I better use a different colored pen. So integration of ax plus b, integration of ax plus b whole to the power n dx comes out to be ax plus b whole to the power n plus 1 upon n plus 1. Always remember to divide the entire answer by the coefficient of x. So this is a linear expression, students. This is a linear expression. It works like x. So if you know the integration of x raised to n, which is x raised to n plus 1 upon n plus 1. So the integration of ax plus b raised to n will also become ax plus b raised to n plus 1 upon n plus 1. But the only thing that you need to care over here is you need to divide the entire answer by the coefficient of x, which is a. So this entire answer should get divided by a. So I can simply write into a. Okay, and then of course a plus c should come. So that's the formula for integration of ax plus b raised to n. So why did I explain all these things to you? Because now I can see that integration of dy, so it's like 1 over here, right? So integration of 1 is going to be what? It's going to be y dy. So dy is not going to come now. So integration of 1 is simply y. It is equal to, you are interested in y equal to f of x, right? So I've got y. 6 is a constant, so it moves outside the integration. So I can write this is 6 outside the integration. And you have 1 upon 3x minus 2 the whole cube, which you can write 3x minus 2 raised to minus 3 dx. So I've taken the 3x minus 2 from the denominator to the numerator. It has gone up, 3x minus 2 raised to minus 3. Now it looks like ax plus b raised to n, where the value of n is minus 3. So I get y is equal to 6, then a bracket 3x minus 2 raised to n plus 1. Minus 3 plus 1 gives you what? It gives you minus 2 whole divided by minus 2 multiplied with the coefficient of x. And what's the coefficient of x, students? It is 3. So it is multiplied with 3. And you should always remember to put a plus c, right? So I'll be getting here y is equal to, now you can easily understand that the 3 times 2, isn't it? Multiplication is going to be 6. It cancels with the 6 in the numerator. So I'll be getting now minus sign, right? So there is a minus sign left in the denominator. So I'm going to get a complete minus sign. 3x minus 2 raised to minus 2 is it going to become 1 upon 3x minus 2 the whole square and plus c. That's the equation of the curve. But see, students, you want to find the value of that c over there, right? For that, now I know this is the equation of the curve. Y equal to minus 1 upon 3x minus 2 the whole square plus c is the equation of the curve. Is the equation of the curve. Now, do you know that the curve is passing through point A? Do you recall the coordinates of point A? So the coordinates of point A, let's go back quickly, was 1, minus 3, and it lies on the curve. If the point A 1, minus 3 lies on the curve, should it not satisfy the equation of the curve? So I go back to my solution. So point A 1, minus 3 lies on the curve. It lies on the curve. Therefore, it should satisfy the equation of the curve. And I know the equation of the curve is this, right? That's the equation of the curve. So you plug the value of x as 1 and the value of y as minus 3. So therefore I can have y as how much? Y is going to be plugged as minus 3. Minus 1 divided by 3 times of x is 1 minus 2 the whole square plus c. So I get minus 3 is equal to, so that's 3 times 1, that's 3. 3 minus 2 is 1. 1 square is 1. 1 divided by 1 is 1. You get minus 1 plus c. That gives you c is equal to minus 2, right? So I've got the value of c as minus 2. So what's the equation of the curve now? So therefore, I can say that the equation of the curve becomes y is equal to, it was minus 1 upon 3x minus 2 the whole square minus 1 upon 3x minus 2 the whole square plus c. So plus the value of c is minus 2. So the plus sign will transform into a minus 2. That's the equation of the curve, right, students? So let's block the answer. That's the equation of the curve. Y is equal to minus of 1 upon 3x minus 2 the whole square minus 2. So that's your B part of the question, right? Find the equation of the curve. Now let's move on ahead, right? So that was the entire question 6. I hope you have well understood the question. We are going to move on to the next part of the question paper, question number 7, which involves functions, right? So this is a question on functions. So the first question that is asked here is, express f of x in the form of x plus a the whole square plus b, and you also state the range of f. So students, you are pretty well aware that when you write y is equal to f of x as any function, then the values of x are called as domain, right? We call them as domain, and the values of y is called as codomain, right? And the values of y which have an association into x, right? The values of y which have an association in the x is called as range. So range is basically a part of codomain. Range and codomain can be same also. So the functions chapter needs to be very clearly remembered, students. So I have a function f. Right? It has a variable x which maps x square plus 2x plus 3 for x is less than or equal to minus 1. So I want to express f of x in the form of x plus a the whole square plus b, and I also want to tell the range of f. That means I want to tell the values of y. Range of f means values of y. Values of y. Okay, so codomain you are basically asked. So what is f of x given to us? What is f of x given to us? So f of x, which is y, is given to us as x square plus 2x plus 3. Now, students, I am very much confident that you are already aware of something called as a completing square method. Completing square method. or you say it as method of completing square. Okay, so it's basically you ignore the last term and you find a new last term. It is given by half into coefficient of x the whole square. So in this equation, you can observe that the coefficient of x is 2, right? That's the term of x. So the coefficient is 2. So I get here 1 upon 2 multiplied with 2, the whole square, which simply comes out to be 1. So your new last term is 1. You're going to get 1. So can I write my x square plus 2x plus 3 equation or expression as x square plus 2x plus, write the 3 as what? 1 plus 2, because the new last term is what? It is 1. You want to bring 1. So x square plus 2x plus 1 plus 2. So x square plus 2x plus 1 is a perfect square. This is a perfect square. So a plus b the whole square it is, right? So x square plus 2x plus 1 is going to become x plus 1 the whole square plus 2. That's your y as f of x. So therefore I can say y, or you can say f of x has come x plus 1 the whole square plus 2. So if you compare the equation with x plus a the whole square plus b, so if you compare with x plus a the whole square plus b, you can easily tell that the value of a is 1 and the value of b is 2. So the first part of the question is answered. Expressing in the form of x plus a the whole square plus b is done. Now you want to find the range of f. Students, you want to find the range of f. Let's see how this can be achieved. Now, what is the domain given to you? What's the domain? Domain is x less than or equal to -1. So the domain is x is less than or equal to -1. I want to get the value of y. So students, x is the domain, y is the codomain, and values of y for respective values of x. Whatever values of x you have, the respective values of y will be called as the range. So I'm trying to get the values of y. So from x less than or equal to -1, I want to transform this. Transform to values of y. Transform to values of y. And what is y that you have? Y is this value, right? So I'm going to get my equation x plus 1 the whole square plus 2 by using this x less than or equal to -1. You can see on the screen, right? From x less than or equal to -1, I'm going to get x plus 1 the whole square plus 2. How it can be done? Observe carefully. So I have x, okay? And I want x plus 1. I have x and I want x plus 1. How can I do it? Just add 1 to both sides of the inequation. So add 1 to both sides of inequation. Right, students? So what do I get? I get x plus 1 less than or equal to -1 plus 1. So remember, if you add or subtract a similar term from both the sides, the inequation bound to remain same. It is going to remain same, right? So if you have 3 less than 7, 3 less than 7. So if you add a particular number, the inequation still remains same. Of course, with a negative sign, you want to be extra careful. Whenever you are putting a negative sign and then you are going to subtract. So of course, it depends what kind of an answer you are going to get. So be very careful with the minus signs. But when there is an addition of the term that's happening, so you can be rest assured that the inequality sign will remain the same. So I'm adding +1 on both the sides. So you get x plus 1 and -1 plus 1. That means I can say x plus 1 is less than or equal to 0. Right, students? X plus 1 is less than or equal to 0. Now look at the expression for y. It is x plus 1 the whole square. I have got x plus 1. I want to do square of it. Now have you realized that x plus 1 less than or equal to 0 means x plus 1 is negative? Means x plus 1 is a negative number. Since it is less than or equal to 0, it's got to be a negative number, right? But students, when you do a square of a negative number, for instance, x plus 1 was -2. Let's assume that x plus 1, the value was -2. So when you do square of -2, what does it give you? It gives you 4, which is greater than 0, right? So if I do squaring on both the sides of the inequation, squaring on both sides of the inequation. You got to be very careful this time that when you do the squaring, x plus 1 the whole square, the inequality sign is going to flip. It will become now greater than or equal to 0. All right, students, because square of a number can never be negative. It always needs to be a positive value. So x plus 1 the whole square greater than or equal to 0 is what we'll be getting. So x plus 1 the whole square is greater than or equal to 0. Now look at the y. So are we now framing y, right? We started from x, we got x plus 1, then we got the square of x plus 1. Now I need a plus 2. So I'm framing x to become y, right? So let's add a 2 on both the sides. The addition is happening. That means the inequation again got to be same. So adding 2 on both sides. Adding 2 on both sides. So I get x plus 1 the whole square plus 2 greater or equal to 0 plus 2. I now know that x plus 1 the whole square plus 2, this term is basically what? Y. So y is greater than or equal to 2. The value of y will always come greater than or equal to 2. So this is what? This is your domain. So I can now say therefore when x is less than or equal to minus 1, right, students? When x is less than or equal to minus 1, which is the range, which is the not range, sorry, which is the domain. So this is the domain. So when x is less than or equal to minus 1, then you can say y is greater or equal to 2. This is your range, right, students? So I have transformed the equation which was given to me, f of x, in the form of x plus a the whole square plus b, and I have also got the range of f. So for doing all this stuff, you get 3 marks, right? Now we will proceed further. I want to find an expression for f inverse of x. So again, very simple. Again, for 2 marks it is. So let us assume that f inverse of x is some value y. Okay, I do not know what is f inverse of x. I'm going to assume f inverse of x as y. So therefore I can say x becomes equal to what? X becomes equal to f of y, right? Now what is f of x given to us? We know what is f of x that is given to us. So f of x is x square plus 2x plus 3, or it is x plus 1 the whole square plus 2, right? F of x is x plus 1 the whole square plus 2. So f of x is x plus 1 the whole square plus 2. That's f of x, right? Let's check it one more time. X plus 1 the whole square plus 2. That's the value of f of x. You can see it on the screen. F of x is x plus 1 the whole square plus 2. So I go back. F of x is x plus 1 the whole square plus 2. Now, x is equal to what? X is equal to f of y. I know what is f of x. If I know f of x, I can get f of y also. So therefore, I can say x becomes equal to f of y. So you just go to f of x and you replace x with y. So in this equation, I'm going to replace x by y, right? I do not know what is f inverse of x. I've assumed that f inverse of x is y. So f inverse of x, if it is equal to y, so f inverse can go on the other side and it can become f. So it's like x equal to f of y. Now I know what is f of x. I know what is f of x. It is x plus 1 the whole square plus 2. If from f of x, I want to get f of y, function has to remain same. Only the variable is changing from x to y. You simply replace x with y. So x gets replaced by y. So replace x by y. You get f of y, right? And f of y was originally equal to x. That means x is equal to x plus 1 the whole square. You are replacing x with y. So it becomes y plus 1 the whole square plus 2, right? You want to get the value of y from here because you are interested in the value of f inverse of x, which is taken as y. So let's isolate the value of y. So from here, can I say x minus 2 will become equal to y plus 1 the whole square? Right, students? X minus 2 is equal to y plus 1 the whole square, which I can say y plus 1 the whole square is equal to x minus 2. It's simply just a transposition of the terms. Okay. Now, if you do square roots on both the sides. You got to be very careful. Y plus 1 the whole square is x minus 2. You are trying to get the value of y. So you want to take square roots. So let's take square roots on both sides. Take square roots on both sides. So now when you take square root, students, you get y plus 1 is equal to, be very careful, it's going to be plus and minus root of x minus 2. It is not just positive root of x minus 2. So when you do square roots, it should be plus and minus both, right? That means y would come equal to minus 1 plus and minus root of x minus 2. You got it? Y equal to minus 1 plus and minus root of x minus 2. Now, I have seen a lot of students doing a foolish mistake over here, taking the positive answers as their preference. But of course, students, this is generally taught by the teachers as well, that you give a preference to the positive sign, but it is not the case always. You want to be very careful which of the two equations are going to be the actual answer. Okay, so this is the trick that I'm going to teach you. Be very careful with such kind of questions. Either of the two answers could be the correct answers. Both of them are not the correct answers. So I can have y becomes equal to minus 1 plus root of x minus 2, or I can have the value of y as minus 1 minus root of x minus 2. Only one of these two answers is the correct answer. Which one is the correct answer is what I need to decide. Now, again, I'm telling you, I have seen students taking y equal to minus 1 plus root of x minus 2 as the correct answer without even checking whether it is really the correct answer or not. Now, sometimes by fluke, the answer comes correct, but sometimes it might not come correct. So you need to know the process of identifying out of the two which is the correct answer. So how do I do it? Observe carefully. Now, I know that for x less than or equal to minus 1, I have already got y as greater than or equal to 2, right? I know for x less than or equal to minus 1, the value of y is greater than or equal to 2. So let's take some random value of x. You can take any value that you want. Just don't take minus 1 and 2 because they are the boundary values. So let's take any other value of x. So when x is, let's say, let's take some number which is less than minus 1, maybe I can take 2. When x is minus 2, what would be the value of y? So I know y is this, right? X plus 1 the whole square plus 2. Y is x plus 1 the whole square plus 2, right? And you said that the value of x is minus 2. So you write minus 2 plus 1 the whole square plus 2. Minus 2 plus 1 is going to be minus 1. The square of minus 1 is going to be plus 1 plus 2. That will give you 3. So the value of y is how much? The value of y is 3. So when x is minus 2, y is 3. So can I write like this? Therefore, f of minus 2 is 3. Right, students? F of minus 2 is 3. So that implies f inverse of 3 is going to be minus 2. Right? Very important, students. Okay. F of minus 2, if it is 3, then f goes on the other side. It becomes f inverse of 3 should become equal to minus 2. Now, I know y. I know y. What is y? Y is f inverse of x. F inverse of x. So I can have my answer either of the two equations that I've got. So I have got y equal to minus 1 plus root of x minus 2. So I can write f inverse of x can become minus 1 plus root of x minus 2, or f inverse of x can become minus 1 root of minus 1 minus root of x minus 2. Now, as I said, only one of them is going to be the correct answer. Which one? I have no clue for. Okay, I do not know which one is the correct answer, but I know that f inverse of 3, f inverse of 3 should become equal to minus 2, right? Let's check this one. Let's check this one. So when x is 3, f inverse of 3 should give me minus 2. Let's check it. So I get f inverse of x is taken as what? 3 minus 1 plus root of 3 minus 2. So what is 3 minus 2? That's 1. Root of 1 is 1. So that gives me -1 plus 1, which is 0. F inverse of 3 has come 0, which is definitely not -2. So this is not the correct answer. So it becomes a common sense that the second one is the correct answer. But let's check it. Let's check it. I know that f of -3, f of or f inverse of 3, not f of -3, sorry for that. F inverse of 3 is going to be how much? It's going to be -2. Let's check it. So f inverse of x is taken as 3, -1 minus root of x is taken as 3, 3 minus 2. So what's 3 minus 2? That's 1. What's root of 1? That's again 1. So that's -1 minus 1, which is coming -2, which is actually the value of f inverse of 3, right? That means I can say that my answer f inverse of x is -1 minus root of x minus 2. That is your correct answer, students, and not the positive one. Okay, usually the students will give the preference to the positive answer. It's not the positive answer which is the correct one, it's the negative answer which is the correct one. So -1 minus root of x minus 2 is your correct answer. So you need to know how to come to this particular conclusion. So many of the teachers I've seen that they sometimes tell that you give preference to the positive sign. No, it's not like that. Okay, of course some of the teachers will show you the right path, how to eliminate which one is a wrong answer from there. Okay, you want to eliminate the wrong answer. So f inverse of x is -1 minus of root of x minus 2. So that's the B part of the question. Okay, now let's move on to the C part. So in the C part, he's asking us solve the equation g of f of x as 13. It's a composite function, students. G of f of x is equal to 13. So for that, I need to first of all get what is g of x. So g is a function. Okay, it is defined, or it maps x for, you have 2x plus 1, right? You have 2x plus 1. 2x plus 1. And what is f? So f is a function where x maps, you have x square plus 2x plus 3, right? X square plus 2x plus 3. So let's go back to the question. X square plus 2x plus 3 plus 2x plus 3. So I know that g of x, students, g of x is 2x plus 1. Therefore, g of f of x is getting replaced by f of x. The variable x got replaced by f of x. So g of f of x will become equal to 2 times of f of x plus 1. Very simple, right? 2 times of f of x plus 1. So this becomes 2 times of what's f of x? It's x square plus 2x plus 3 plus 1. So that becomes 2x square plus 4x plus 6 plus 1, or I can write 2x square plus 4x plus 7. That's g of f of x. But what's the value of g of f of x given to you? The value of g of f of x is given to us as 13. So I can write 2x square plus 4x plus 7 is equal to 13. So I can write this is 2x square plus 4x. So 13 will shift its side. It will come on the other side, right? So 13 shifts the other side. It becomes -13. So it's like 7 minus 13. So 7 minus 13 will give you what? 7 minus 13 will give you -6 equal to 0. You can again observe that it's a quadratic equation. There is a common multiple of 2. So you can divide throughout by 2. So this implies it's going to be x square plus 2x minus 3 equal to 0, right, students? Isn't it? Divide throughout by 2. So x square plus 2x minus 3 equal to 0. And this is what? X square plus 2x minus 3 equal to 0 is a quadratic equation. The last term is -3. The factors of -3 is +3 multiplied with -1, right? +3 into -1, if you do, you get -3. And if you do +3 and -1, you get a +2. That means the factors are x plus 3 and x minus 1 equal to 0, right? X plus 3 into x minus 1 equal to 0. So therefore, I can have the value of x as what? So x will become equal to -3. So x plus 3 x plus 3 equal to 0 will give you x equal to minus 3, or x minus 1 equal to 0 will give you x equal to 1. Right, students? But what is said about x? Go back to the question. Go back to the question. X is less than or equal to minus 1. X is less than or equal to minus 1. So when you come back here, I can say we know x is less than or equal to minus 1. So can this be the solution? Can x become equal to 1? The answer is no. X cannot become equal to 1 because x has to be less than or equal to minus 1. So therefore, I can say x is equal to minus 3 is our correct answer. You got that? That's how the question is solved. Right, students? So now we are going to proceed ahead with the next question. Students, now we are going to move ahead with the next question, question number 8. Over here, you want to find the equation of a circle. Now you can observe there are 3 points on the circle given to us. The points A, whose coordinates are 7, 1, the point B, whose coordinates are 7, 9, and the point C, whose coordinates are 1, 9, are on the circumference of a circle. Find the equation of a circle. Now, students, you want to really know this well, that to find the equation of a circle, we will be using something called as a center radius form. I hope everyone is aware of the center radius form, which looks like x minus h the whole square plus y minus k the whole square is equal to r square, where h and k are what? They are the coordinates of the center of the circle. So center of the circle will have coordinates h comma k, and r is what? R is the radius of the circle, right? So h comma k is the center of the circle and r is the radius of the circle. So to write the equation of a circle, I will need 2 things. One, the center of the circle, and the other one is the radius of the circle. Now, in this question, you are provided with the points lying on the circumference of the circle. That means the points are on the circle. I do not have the center of the circle. I also do not have the radius of the circle. So I'll have to get the center, I'll have to get the radius of the circle, and then I can make use of the center radius form to get the equation of the circle. How it can be done? Let's observe. So I want to find the equation of the circle. There are 3 points given to us. I'm going to draw a circle first of all. Let's draw a circle, students. Let's draw a circle. So I have a circle, okay, and I am given 3 points on this circle. 3 points are given on the circle. Okay, so I will take a point as the center of the circle. Okay, let's say this point is the center of the circle. There are 3 points A, B, and C. Okay, so I can take the point A maybe somewhere here. That's point A. Okay, this is point A. This is point A, and the coordinates of the point A is given to us as 7, 1, 7, 1, right? Then I will take the coordinates of point B. So for that, first of all, I need to take point B. Let's say this is point B somewhere. Okay, so that's point B. I take this as point B, and the coordinates of point B is given to me as 7, 9. So I take this as 7, 9. And then there is some point C I will take. There is some point C. Okay. So this is point C I can take. This is point C. And the coordinates of point C are given to me 1, 9. So coordinates of point C are 1, 9. You got that? Okay. So I have taken random positions of the point, students. Okay. It is not an exact diagram, I can say. Okay, it's not an exact diagram, but it's an appropriate diagram. Okay, so what I need over here to write the equation of the circle, I will need the center of the circle. I do not have the center of the circle. I will need the radius of the circle. I do not have the radius also. So let's say point P is the center of the circle and its coordinates are standard h, k. We will take the coordinates of the center if it is unknown as h, k. Then tell me who is PA? What is PA here? Is PA the radius of the circle? So PA is the radius of the circle. What about PB? Is PB also the radius of the circle? So that's R. And what about PC? PC is also the radius of the circle. So they are all radius of the circle, PA, PB, PC. Okay, so I am now trying to find the coordinates of the center of the circle. So I now know that let P, H comma K is the center of the circle, right? So therefore I can say PA is equal to PB is equal to PC. They are all the radius of the circle, right? Now, do I know the coordinates of point P? Of course, they're unknown, but it is h comma k, right? So I now know the coordinates of P. It is h comma k. The values are not known to me. So can I say I can make use of the distance formula, students, to get the distance PA? I can again make use of the distance formula to get the distances of PB and PC also. So if PA is equal to PB, can I say PA square must be equal to PB square, right, students? I can say PA square is equal to PB square. And can I also say that PB square will become equal to PC square, right? And I can say PB square is equal to PC square, isn't it? So I have done squares of the distances. The only reason of doing squaring is I'll be able to make use of the distance formula very easily. What's the distance formula? So distance formula goes like square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. But if you do the square of this distance, the square root sign will vanish from there, right? So let's consider PA square equal to PB square. Let's consider PA square is equal to PB square. So therefore, by distance formula, by distance formula, PA square. So let's get PA square. So PA square would be h minus 7 the whole square, right? H minus 7 the whole square plus k minus 1 the whole square. That's the value of PA square. This would become equal to PB square, which is h minus 7 the whole square plus k minus 9 the whole square, right, students? H minus 7 the whole square plus k minus 9 the whole square. So if you observe the left hand side and the right hand side, can you easily understand that this h minus 7 the whole square is present on both the sides with the same sign? So this h minus 7 the whole square term will simply get cancelled, right? It will get cancelled. So now you're with k minus 1 the whole square and k minus 9 the whole square. So I can do the squaring of it, right? I can expand it. So I get k square minus of 2k plus 1 is equal to k square minus of 18k plus 81, right, students? Isn't it? I've done the squaring of the left hand side and the right hand side. Now again, from both the sides, again I can see that the plus k square and the plus k square term will get cancelled. Now the entire equation is of k and the constants, right? There is a k and then there is a constant. So what I can do is I can send the minus 18k on this side, isn't it? It becomes plus 18k. You have a minus 2k on the left side. So plus 18k minus 2k should give me 16k is equal to the 1 will transfer on the other side, isn't it? So there is 81 on the other side. So 81 minus 1, that will give you 80. So 16k is equal to 80. That implies that k is going to be 5. See, I've got the y coordinate, isn't it? So h comma k is the x and the y coordinate of the center. So I've got the value of k, which is 5. So that's my first answer, right? K is equal to 5. Now I want to get the value of h. For that, I'm going to choose PB square and PC square. Now it does not matter, student, if you take PA PB and PB PC, or if you take PA PB and PA PC, you will still end up with the same answer. So it is as per your convenience which you want to take. So here I have selected PA square and PB square because I could have been able to cancel the h minus 7 term. Let's select PB and PC, then you can cancel the k minus 9 term. That's the reason I've taken PB square and PC square. So now let's consider PB square and PC square. PB square is equal to PC square. So again, I'm going to make use of distance formula. There is no need to write it now. So PB square will give me what? PB square will give me H minus 7 the whole square plus K minus 9 the whole square is equal to PC square. So PC square is H minus 1 the whole square plus K minus 9 the whole square. So from both the sides, which term is going to get cancelled? This time K minus 9 the whole square term will get cancelled, and the H minus 7 and H minus 1 the whole square terms will get expanded and simplified. So I'm going to cancel the K minus 9 the whole square, K minus 9 the whole square from both the sides. Let's expand H minus 7 the whole square. So if I expand H minus 7 the whole square, I'll be getting H square minus of 14H plus 49 is equal to H square minus 2H and plus 1, right? So again, I go further and cancel the H square and the H square from both the sides. You collect all the terms of H on one side and all the constants on the other side. So I can send the minus 14H on this side, it becomes plus 14H. So 14H and minus 2H. So 14H minus 2H will give me 12H. And send the 1 on the other side. So this 1 will go on the other side. There is 49 present on that side. So 49 minus 1, that gives you 48. So 12H is equal to 48. That implies H will become equal to what? So it's 48 divided by 12, which is 4. See, students, I've got the value of H also. That means now I have the coordinates of the center. So therefore, I now remember the center was given by P, whose coordinates were H comma K. Therefore, the center now has coordinates H is 4 and K is 5. 4 comma 5. Now I have got the center. Now I need the radius. So you can select any one of the radii, either a PA square or a PB square or a PC square. Everybody is a radius here. PA, PB, PC, every one of them is a radius. You select the most convenient one that you feel like. So I'm going to select PA square. As per the convention. So because it is first, I'm taking PA square. So now for radius, let us consider PA square. So I now remember PA square was this term. Observe, PA square was H minus 7 the whole square plus K minus 1 the whole square, right? So H minus 7, so H is 4. Right, so I've got the coordinates of the center. I can write the coordinates of the center if I have to. So center is 4 comma 5. So I can write here 4 comma 5. Those are the coordinates of the center. So that's 4 minus 7 the whole square, 4 minus 7 the whole square plus 5 minus 1 the whole square plus 5 minus 1 the whole square. So that should give me what? That should give me 4 minus 7, which is minus 3. Square of minus 3 will give me 9 plus 5 minus 1, that's 4. 4 square will give me 16, which comes out to be 25. That means the radius of the circle will come how much? So radius, which is PA, is going to be root of 25, square root of 25. No negative sign will come here because it's the radius. Radius cannot be negative. It is always going to be positive value. So root of 25 will take only positive answer. That's 5. So I have the radius now. Therefore, I can say equation of the circle by something called as the center radius form. And what is center radius form? It is x minus h the whole square plus y minus k the whole square is equal to r square. So I write x minus the value of h. The value of h was 4, if you remember, right? And the value of k was 5. So h minus 4 the whole square plus y minus 5 the whole square is equal to radius r square, which is 25, right? If you want, you can simplify it further and write the equation as x square minus 8h and plus 16, right? Not 8h, sorry. So it's going to be x square minus 8x plus 16 plus y square minus 10y plus 25 is equal to 25. So from both the sides, again, you can cancel the 25 and 25. So you will be left with, you can rearrange the terms with the highest powers at the beginning. So write x square, then plus y square, then minus 8x and minus 10y and plus 16 equal to 0. So this equation is called as the general equation of the circle. Did you get that? That's how we find the equation of the circle. You could have left the answer at this particular place also. This is the center radius form. Okay, x minus h the whole square plus y minus k the whole square equal to r square. So any one of the answers will do. You getting? So that's how we solve the part A. Okay, so that will fetch you 5 marks. Now let's go to the next part of the question. The next part of the question demands to find the equation of the tangent to the circle drawn at point B. So I go to the circles diagram, and at point B, I want to draw a tangent, students. I'm going to draw a tangent at point B. So let's say this is the tangent which is drawn at point B. Okay, I've drawn a tangent at point B. That's a tangent at point B. Now, what is said about this tangent? So tangent is drawn at point B. I want to find its equation. Okay, what's the equation of the tangent? Now, students, I know that tangent is a line, isn't it? A tangent is nothing but what? It's a line. If I want to find the equation of a line, then basically what do I need? To find the equation of a line, I will need the slope of the line and one point on the line. I need the slope of the line and I need a point on the line. So I can make use of something called as a slope point form to find the equation of the line, which is y minus y1 is equal to m into x minus x1. Now, are you aware that the tangent and the radius are both perpendicular to each other at the point of contact? So point B is a point of contact. Point B is a point of contact. So the tangent and the radius will definitely be perpendicular at the point of contact. So I can write here tangent at point B, tangent at point B is perpendicular to the radius at point B. Right, students? So tangent and the radius are both perpendicular to each other at the point of contact. Now, if two lines are perpendicular, then what do you know about the product of their slopes? Don't you recall that m1 into m2 will become equal to -1, where m1 is the slope of the first line and m2 is the slope of the second line, or you can say the gradients, right? So the product of the slopes or gradients of the two perpendicular lines is equal to -1. So can I say from here slope of tangent multiplied with slope of radius should be equal to -1, right? Slope of the tangent multiplied with slope of the radius will become equal to -1. So I can simply say, therefore, slope of tangent is equal to -1 divided by slope of radius. Slope is a gradient, students, right? So I can easily get the slope of the radius from here. Did you see that the radius has coordinates P 4,5 and B 7,9? So I can get the slope of PB, right, students? So therefore I can say slope of radius PB, because PB is the radius which is perpendicular to the tangent. So I'm going to get the slope of radius PB. So I'm going to make use of the 2-point form which says y2 minus y1 divided by x2 minus x1, right? So let's go back to the diagram. So y2 minus y1. So it's like 9 minus 5, y2 minus y1, 9 minus 5 divided by x2 minus x1. So 7 minus 4. So I can write here 9 minus 5 divided by 7 minus 4. So what's 9 minus 5, students? So 9 minus 5 is going to be 4. 7 minus 4 is going to be 3. So slope of the radius is 4 upon 3. If the slope of the radius is 4 upon 3, then the slope of the tangent would become how much? So slope of the tangent becomes equal to -1 upon 4 upon 3, or I write -3 by 4. That's the slope of the tangent. So I have the slope of the tangent. I know that the tangent is drawn at point B. Okay, so also tangent is drawn at point B. Therefore, I can get the equation of tangent by something called as slope point form, which is y minus y1 is equal to m into x minus x1. So I get y minus. What were the coordinates of point B? Let's go back here. The coordinates of point B, it was 7, 9. So y minus 9. Point B had coordinates 7, 9, right? So y minus y1. So y minus 9 is equal to, what's the slope? So slope is minus 3 upon 4, minus 3 upon 4, x minus x1. So x minus 7. So you can simplify it. So it can be 4y minus 9 4s are 36 is equal to minus 3x plus 21, or you can simply say 3x plus 4y is equal to 36 plus 21, right? The minus 36 goes on the other side. So that's 6 plus 1, 7, 3 plus 2, 5. So 3x plus 4y is equal to 57, or you can simply keep the equation as y is equal to minus 3 upon 4x, right? And then minus 3 upon 4 multiplied with minus 7, that would give me plus 21 upon 4, and the minus 9 goes on the other side, becomes plus 9. So you can write the equation as y is equal to minus 3 upon 4x plus, you can cross multiply, and you get it as 57 upon 4. You can write the equation like this also. So whatever equations you write, either you write 3x plus 4y equal to 57, or you write y equal to mx plus c form, both the answers will fetch you the full marks. So this is how you can find the equation of the tangent. And then we have also solved for the equation of the circle. So that was question number 8, students. Okay, so now let's proceed ahead. We are done with question number 8. We're going to go to question number 9 now. So this question is again of series where you have an arithmetic and a geometry progression question. So look at the first part of the question. It says the first term of a progression is cos theta. Okay, and theta lies from 0 to pi by 2. It means that theta is in the first quadrant, right? The first term of a progression is cos theta. For the case where the progression is geometric, see, very clearly mentioned that the progression is what? The progression is geometric, right? The sum to infinity is 1 upon cos theta. Now, students, you want to remember that cos theta from 0 to pi by 2, if it is a first quadrant, cos theta will be lying between 0 and 1, right? Cos theta is definitely lying between 0 and 1. And moreover, it is not told that theta becomes equal to 0. Theta is greater than 0. Theta is less than pi by 2. So cos theta will be less than 1, right, students? It will be greater than 0 but less than 1. So cos theta is a value which is less than 1. So it is told that the progression is geometric and the sum to infinity is 1 upon cos theta. So show that the second term is cos theta into sine square theta. So I want to find the second term of the geometric progression. Now, students, you should be aware that any term of the geometric progression, okay, the nth term of a geometric progression, the nth term of a geometric progression is given by the formula. So we denote it by Tn. It is going to be formula a r raised to n minus 1. A is your first term, a is the first term, and r is the common ratio. Okay, the second term divided by the first term, or the third term divided by the second term, or the seventh term divided by the sixth term, that is your common ratio. So to get the nth term, the formula is a r raised to n minus 1. So if you want to find the second term, the value of n will become 2. So n is the position of the term. N is the position of the term. So you need to know these notations and this formula to find the nth term or the second term of the geometric progression. So now, students, you should also remember that sum of an infinite series, sum of an infinite geometric progression, sum of an infinite series is given by S infinity, and the formula is A upon 1 minus R. You know what is A, right? A is the first term and R is a common ratio. A is the first term and R is a common ratio. So I am told that the sum of an infinite series, sum up to infinity, is 1 upon cos theta. So S infinity is 1 upon cos theta. So I can write here 1 upon cos theta is equal to A. A is the first term, right, students? A is the first term. So in the question itself, it is told that the first term is nothing but what? The first term of the progression is cos theta. The first term is cos theta. So A is cos theta. So I can write cos theta here divided by 1 minus R. So I know to find any term of the geometric progression, the formula is A R raised to n minus 1. A is the first term, R is a common ratio, and n is the position of the term. So I already had A, the first term. I'm interested in the value of R now. So you observe that the sum up to infinite term is given to us. I'm using the formula A upon 1 minus R. So there is only one unknown now, and that unknown is R. So I can cross multiply, students. I can cross multiply and write 1 minus R, right? 1 minus R multiplies with 1. You get 1 minus R is equal to cos theta into cos theta is equal to cos square theta. So I get 1 minus cos square theta is equal to R. You have transferred the cos square theta on the left and R on the right. So you get 1 minus cos square theta is equal to R. And you know that 1 minus cos square theta is basically sine square theta. So R has come sine square theta. You got that? R is sine square theta. Now I have the value of R. I know the value of A. I can get any term, right? So nth term, if you remember, it is given by what formula? The nth term is given by AR raised to n minus 1. So the second term. Therefore, see, the question says, show that the second term. So second term would become equal to T2, right? It is equal to A R raised to n minus 1. So that's 2 minus 1. So it's basically A multiplied with R. What was A? Do you remember that the first term A was cos theta, and the value of R that you have got is sine square theta. So cos theta multiplied with sine square theta. That's your second term. See, I have shown that the second term is cos theta into sine square theta, right? Now, the second part of the question says find the sum of the first 12 terms when theta is pi by 3, or 1 upon the times of pi. It's same as pi by 3, right? Sum of first 12 terms when theta is pi by 3. Now, your R is sine square theta. Now, do you know that for theta lying from 0 to pi by 2, right? Theta lying from 0 to pi by 2, sine theta will lie between 0 to 1. Therefore, sine square theta will also lie between 0 to 1. So it basically means that sine square theta is less than 1. Therefore, I can say sine square theta, that is R, is less than 1. So you want to remember this, because Sn is given by the formula A R raised to n minus 1 upon R minus 1 when R is greater than 1. Okay. When R is greater than 1. At that time, you use the formula A R raised to n minus 1 upon R minus 1 to find the sum of n terms of a geometric progression. So this is sum of n terms of a geometric progression. Okay, so when R is greater than 1, we use one formula. And when R is less than 1, the formula changes to A into 1 minus R raised to n upon 1 minus R. So here R is less than 1. So in our case also R is less than 1. So I'm going to make use of the second formula to find the sum of first 12 terms. So I can write here S12 is equal to A into 1 minus R raised to n, which is 12, upon 1 minus R. So A is the first term and R is the common ratio, right? So A is given by cos theta. But what is theta given to us? Theta is given as pi by 3. So I can write this as cos pi by 3. So pi is 180. 180 divided by 3 is 60. Cos of 60 is 1 upon 2. So A is 1 upon 2. The common ratio R is sine square theta, right, students? So I write sine square of theta is pi by 3. So it's basically sine pi by 3 the whole square. Now you know that sine of pi by 3 is what value? So sine pi by 3 means sine 60. It's root 3 upon 2. So that's root 3 upon 2. That's root 3 upon 2. Something has gone wrong. So that's root 3 upon 2 square. So I get root 3 upon 2 the whole square. Okay. Root 3 upon 2 the whole square. That would come out to be 3 upon 4. Okay. That's 3 upon 4. Right, students? The value of r, which was sine square theta, has come 3 upon 4. So this is 3 upon 4. 3 upon 4. Right? So now I've got the value of r as 3 upon 4. I have the value of a, which is 1 upon 2. I can get S12, isn't it? So S12 will become equal to what? So therefore, S12 becomes equal to a. So the value of a is 1 upon 2 multiplied with 1 minus r raised to 12. So r is 3 upon 4. So 3 upon 4 whole to the power 12, close the bracket, whole divided by 1 minus r. So 1 minus the value of r, which was 3 upon 4. You got it? You want to simplify this. So of course, you'll need a calculator. So I'm going to make use of the calculator to get this answer. So it's like 1 divided by 2. Okay, so 1 upon 2. This multiplies with, we'll put a bracket, then 1 minus, put another bracket, right? 3 divided by 4, close the bracket, use the x to the power key, and in that blank space, you'll put 12, close the bracket, you'll get the numerator. Okay, some answer has come. This gets divided by 1 minus 3 upon 4 and close the bracket. So the answer has come 1.936647296. Question says up to 4 significant figures, right? The question demands up to 4 significant figures. So I'll write 1.93664, 1.93664. So for 4 significant figures, my answer would become 1.937. So the sum of first 12 terms, the sum of the first 12 terms when theta is pi by 3 is 1.937. So I can write here S12 is 1.937. That's my answer. Okay. Now we can proceed further to part B. Okay. Let's solve for part B. Now it is told that for the case where the progression is arithmetic. Now previously the progression was geometric, right? The progression was geometric. Now the progression is arithmetic. Now for an arithmetic progression, you should remember that the nth term, students, the nth term Tn is given by a plus n minus 1 d. That's how we find the nth term. D is the common difference. Again, a is the first term, a is the first term, and this time d is the common difference. It's a common difference. That means you take the difference between two consecutive terms. So if the progression becomes now arithmetic, the first two terms are again cos theta and cos theta sine square theta respectively. So the first two terms means what? T1 and T2, right? T1 and T2. So T1 is cos theta, T1 is cos theta, and T2 is cos theta sine square theta, right? So you can find the value of D, which is the difference, okay? The common difference, the constant difference throughout the progression. So therefore I can say D is going to be T2 minus T1. So that's cos theta into sine square theta minus cos theta. So I can bring the cos theta common. You get sine square theta minus 1. Bring the minus cos theta common. So see what happens. If you take out a minus cos theta common, you get 1 minus sine square theta. And you know that 1 minus sine square theta is cos square theta. So I get minus of cos theta into cos square theta. So that's minus of cos cube theta. So that's the common difference D. That's minus cos cube theta. I want to find the 85th term. So I know that nth term is given by a plus n minus 1 d. So for the 85th term, and theta is how much? Theta is pi by 3. So 85th term, T85 is a plus n minus 1. 85 minus 1, difference is d. So it's like a plus 84d, right? A is the first term. First term is cos theta. A is cos theta. And what's the value of theta given to us? The value of theta is pi by 3. So this is cos of theta is pi by 3. So you know that pi by 3 is what? Pi is 180. 180 divided by 3 is 60. Cos of 60 is 1 upon 2. So the value of A is 1 upon 2, right? A is 1 upon 2. And the difference is minus of cos cube theta. Difference is minus of cos cube theta. So minus of cos cube of theta is pi by 3. So again, what's pi by 3? Cos of pi by 3 is 1 upon 2. Minus of that, right? Minus of cos cube theta. So minus of 1 upon 2 cube, it comes out to be minus 1 upon 8. So d is minus 1 upon 8. So I can now have T85, the 85th term as A. So what's the value of A? It's 1 upon 2 plus 84 into what's D, the common difference? It's minus 1 upon 8. So you can simplify. So I can have 1 upon 2 minus 84 upon 8. That gives me minus 10. I have got minus 10. You just want to do the simplification, students. Therefore, I can say that the 85th term of an arithmetic progression is minus 10. That's your answer, students. Okay, that's your answer. Fine. Okay, so this is your B part. Now it's going to be the next question. So I hope this question is well understood to you, isn't it? The question was based on progressions. So let's proceed with the next question now. Question number 10, students. So in question 10, what is said to us? What is given to us? So the diagram shows a sector ABC, which is a part of a circle of radius A. So there's a diagram. Okay, the diagram is given to us, and it shows a sector ABC, and it is a part of a circle with radius A. The points D and E lie on AB and AC respectively, and are such that the length of AD is equal to the length of AE, and that value is KA, where K is less than 1. So it is also mentioned to us that K is less than 1. The line DE divides the sector into two regions which are equal in area. That means the area of the triangle ADE. So I can write here area of the triangle ADE is equal to the area of the region, the rest of the region. So that's BCED. So area of region BCED. So these two areas are exactly equal. K is less than 1, already mentioned to us. So for the case where angle BAC, so angle BAC is this angle. Right, students? This is angle BAC. So for the case where angle BAC is going to be 1 upon 6 pi or pi by 6 radians. So this angle is given to us as pi by 6 radians. Okay. So pi by 6 radians, or you can say it is 30 degrees. Pi is 180. 180 divided by 6. So that's 30 degrees. So pi by 6 radians, or I can say 30 degrees. Find the value of K correct to 4 significant figures. It's a question for 5 mark, students. You want to find the value of K. Okay. Now what is told about the triangle ADE and the region BCAD? Both these regions have the exact same area. So now I want to find the area of the triangle first of all. Okay. So I know that the area of the triangle, there is a formula. One of them is the most basic one. You all know that half base into height. But to make use of this formula, half base into height, I should be having a base and the height of the triangle. None of them is provided. No base is there, no height is there. But students, you might be recalling that if you have a triangle, let's say we have a triangle ABC like this. Okay, that's triangle ABC. Then the side opposite to angle A is denoted by small a. Side opposite to angle B is denoted by small b. Side opposite to angle C is denoted by small c. Then the area of the triangle ABC is given by half AB sine C or half BC sine A or half CA sine B. So you should know the lengths of two sides and the included angle between those two sides. So the length of AC and length of BC is known, and you should know the angle between these two sides, AC and BC. Okay, so if you know this, you can get the area of the triangle. So I can easily understand in my case over here, I can have the area of the triangle, right? So this is the triangle that is given to me. I can get the area of this triangle by using the same formula that I've discussed with you people just now. Okay, I can use the area of the triangle half into product of two sides whose length is known to me. Product of two sides whose length is known to me. So I know length of AD and length of AE, and both of them is K times of A, and the angle between them is also known to me. So AD and AE, I know the angle between these two sides, and the angle is pi by 6. It should be in radians, students. Okay, so try and keep the angles in radians now. So area of triangle ADE, let's get first of all the area of triangle ADE from the diagram. So area of triangle ADE is going to be 1 upon 2 multiplied with the two known sides KA and KA. So I can write here KA multiplied with again KA, and the included angle between them, the sine of the included angle between them must be known to us. So sine of pi by 6 multiplied with sine of pi by 6. Sine of pi by 6. So that should give me, so what is sine pi by 6, students? Pi is 180. 180 divided by 6 is 30. Sine 30 is 1 upon 2. So 1 upon 2 into 1 upon 2, that gives me 1 upon 4. K into K gives me K square A square. So my answer would be K square A square upon 4. That's the area of triangle ADE. Right, students? Now I know the area of triangle ADE. I want to try and get the area of this region BCED also. I want to find the area of the region BCED as well. Right, students? I'm going to get the area of BCED also. So how do I get this area? Let's figure it out. So do you know what's the formula for area of the sector? Students, what's the formula for area of the sector? So area of the sector is given by half r square theta. Theta is in radians. Theta must be in radians. Half r square theta, right? I know the radius is A, isn't it? Now from this sector, if I remove the triangle, will I get the area of the region BCED? So I can say area of BCED will become equal to area of sector. What's the name of the sector? It's ABC, area of the sector ABC, minus area of the triangle ADE, right? Area of triangle ADE. If I do this, I'll get the area of the region BCED. So area of the sector is given by half r square theta minus area of the triangle ADE is already obtained by us as K square A square upon 4. So I can write here K square A square upon 4. Now tell me, what was the radius? The radius was A. The radius of the circle is A. So this would come out to be A square. What's theta? So the value of theta is pi by 6. So A square into theta is pi by 6 upon 2. So pi by 6 multiplies with 2, it's 12 minus k square a square upon 4. If you want, you can take out the a square upon 4 common. So you can take out a square upon 4 common, or you can leave it as it is. Let's leave it as it is. So that's the area of the region BCED. But according to the question, it is told to us that the green colored region and the orange colored region, they're both equal. So I can say, since area of triangle ADE is equal to area of the region BCED, I can add area of the triangle ADE, which is k square a square upon 4, is equal to area of the triangle BCED, which is pi a square upon 12 minus k square a square upon 4. Okay, so you can collect the two terms together. K square a square upon 4, you can collect it together. So this term goes here. You get 2 times of k square a square upon 4, which is k square a square upon 2 is equal to pi a square upon 12. So a lot of things will get cancelled. So first of all, I can cancel the a square. I can cancel the 2 and the 12. You're left with 6. So the value of k square is pi by 6. So I can write here k square is equal to pi by 6. So what does k come? K would come plus or minus root of pi by 6. But it is told to us that k is less than 1, right? K is less than 1. And since k times of a you want to find, k times of a is a length, AD is a length, AE is a length. So k cannot be negative, right? So k, the negative value needs to be discarded. So I'll just take k as root of pi upon 6. Okay, so make use of the radian mode. Do not use pi as 180 now here. So I'll use shift of pi divided by 6. I get some answer. Okay, and then square root of that answer. So that comes out to be 0.7236. You want to write 4 significant figures. So I write 0.7236. 0.7236. That's the value of k. Find k correct to 4 significant figures. So I have solved the first part of the question, which will fetch me 5 marks. Let's go to the second part now, the B part. Now he's saying for the general case in which angle BAC is theta radians. So theta was given to me as pi by 6 in my diagram, right? Theta was given to me as pi by 6. Now I'll keep the value of theta as theta only. Now I'll not write it as pi by 6. Okay, in general case, when the angle BAC is taken as theta radians, theta is lying between 0 to pi by 2. Okay, so nothing was mentioned here whether theta was lying between 0 to pi by 2 or not. But now it is mentioned that theta lies between 0 and pi by 2. It is given that theta upon sine theta is greater than 1. Find the set of possible values of k. The question is for 3 marks. Okay, now let's go back here. So angle BAC is theta radians. I have just now proved that k square a square upon 2 is equal to pi a square upon 12, right? So I'm going to make use of the same concept. So in this case, I do not know what's the value of theta now. Okay, theta is not known to me. So again, area of the triangle ADE is equal to area of the region BCED, right? So we are going to solve the general case. So for a general case, area of the triangle, it is given by half. It was the lengths of the two sides was k, and the angle is now theta. The angle is now theta. So half KA multiplied with KA into sine of theta. So nothing will happen to theta. Theta will remain theta. This is the area of the triangle. Is area of triangle, right? And what's the name of the triangle? It's ADE. Area of triangle ADE. So therefore, I can say that the area of triangle ADE is simply k square a square sine theta whole divided by 2. I can call this as equation 1. Now let's get the area of the region BCED, right? Region BCED. So it's going to be again area of the sector, which is half r square theta. minus area of the triangle. So area of region B, C, E, D. That's the area of the sector. So half r square. R is a radius, but the radius, if you can see, is a. So half a square into half r square theta. So half a square theta. The value of theta is not known to me. Minus area of the triangle. So it was k square, a square sine theta upon 2. I'm going to call this as 2, but I know 1 and 2 are equal, but 1 is equal to 2. So I can write k square, a square sine theta upon 2 is equal to half a square theta minus k square, a square sine theta upon 2. You can collect the terms of k square, a square sine theta upon 2 together. So I'll be getting k square, a square sine theta is equal to half a square theta. From both the places, the term a square will get cancelled, right guys? Isn't it? So I get k square is equal to what? So this implies k square is equal to theta upon 2 sine theta, right? Theta upon 2 sine theta. But what is told about theta upon sine theta? It is greater than 1. But I know that theta upon sine theta is greater than 1, right? So I can divide both the sides by 2, or I can multiply both the sides by 1 upon 2. So I can write here multiply both sides by 1 upon 2. So even if you multiply both sides by 1 upon 2, the inequality sign is not going to change. So I write 1 upon 2 into theta upon sine theta is greater than 1 upon 2 into 1. So I write theta upon 2 sine theta is greater than 1 upon 2. But what is theta upon 2 sine theta? Just now you have proved that theta upon 2 sine theta is k square. So I can write here that k square is greater than 1 upon 2. Right, students? So if k square is greater than 1 upon 2, you want to find the value of k. Did you see the question? Find the set of possible values of k. So you want to tell what are the values of k. So if k square is greater than 1 upon 2, let's remove the inequality sign. So let's consider k square is equal to 1 upon 2. That implies k would come out to be plus and minus 1 upon root 2, right? K would come out to be plus and minus 1 upon root 2. So if I make a number line over here, if I make a number line like this, okay, so this is k, where it is minus 1 upon root 2, somewhere it will be 0, somewhere it is going to be 1 upon root 2. And do you recall, now 1 upon root 2, if you try and get the value for, let me try and get the value of 1 divided by root 2. So if you press the S and D button, it comes out to be 0.7071. 1 upon root 2, this value is 0.7071. Now, do you recall that k was less than 1 and k has to be positive? It cannot fall below 0, right? Because k is multiplied with the length and the length cannot be negative. So k has to be greater than 0, but it has to be less than 1, right? So I can write here, but k is less than 1, right? And k also needs to be greater than 0. So when I say k is plus and minus 1 upon root 2, and k square needs to be greater than half. Students, this is very important. Try and understand this. So if you plug the value of 0 into this inequation, that's the inequation which must be satisfied by the values of k. So if you plug the value of k as 0, which is lying between minus 1 upon root 2 and plus 1 upon root 2. So 0 square greater than half. The answer is no. 0 square, which is 0, 0 is not greater than half. So 0 is not the part of the solution. So you have to take 1 upon root 2 or a value which is more than 1 upon root 2, right? So this is 1 upon root 2 and this is where somewhere you'll get 1. So I can say since k is less than 1 and k needs to be greater than 1 upon root 2, it cannot fall beyond 1 upon root 2. It has to be greater than 1 upon root 2. I can say that the k will have a range. It will be greater than 1 upon root 2, but less than 1. This is what your answer should be, students. K is lying between 1 upon root 2 and 1. You got that? So that's your question number 10. I hope you have understood well, students. Now it's time for us to go to the next question. So let's proceed for the next question, which is question number 11. So in the 11th question, students, you can observe, you want to find the x coordinate of point A. So there is a curve. The diagram shows the curve whose equation is given to you as y is equal to 9 times of x raised to minus half minus 4 times of x raised to minus 3 upon 2. Right? So there is a curve that's the equation of the curve given to us. And you can see that the curve is crossing the x-axis at the point A. So point A is a point where the curve and the x-axis are intersecting. The first question says you want to find the x coordinate of point A. So it's a very simple question. If point A is a point on the x-axis, since point A is a point on the x-axis, you can easily understand that its x coordinate will be some value, whereas the y coordinate, students, what about the y coordinate? So y coordinate of this point A, y coordinate of the point A is going to be simply 0 because there is no displacement in the y direction. That means the y coordinate of the point is going to be 0, right? Now, since I know that the curve has equation y is equal to 9 x raised to minus half minus 4 x raised to minus 3 upon 2, and point A lies on the curve, so it should satisfy the equation of the curve as well. So I go to the equation of the curve and I simply substitute y as 0. So I can write here, since point A is on the x-axis, its y coordinate is equal to 0. Also, point A lies on the curve, therefore it satisfies the equation of the curve. So it's very simple. Just plug the value of y as 0 in the equation of the curve. So I can call this equation as equation number 1. So you say plug y equal to 0 in equation 1. So I'll be getting 9 times of x raised to minus half minus 4 times of x raised to minus 3 upon 2 is equal to 0. Right, students? Now you already are aware that a raised to minus half, is it 1 upon a raised to half, which can be written as 1 upon root of a, right? And a raised to minus of 3 upon 2 can be written as 1 upon a raised to 3 upon 2, which would become 1 upon a root a, right? So we already have the knowledge of indices, right? A raised to minus half, a raised to minus 3 upon 2, how they convert into radicals is shown to you. So I can now say here, this is, so one more thing that you can understand here is the 9 which is multiplied with the bracket. So 9 can be sent on the other side where you have 0 divided by 9, that becomes 0. So I simply get 1 upon x raised to minus half is root of x minus 4 upon x root x is equal to 0. Right, students? Isn't it? So I'm going to go further now. I'm going to go further and I can take out 1 upon root x common, right? Let's take out 1 upon root x common. So if I take out 1 upon root x common, I'm left with 1 minus 4 upon x equal to 0. That gives me x minus 4 upon x root x equal to 0. So you know that a fraction can become 0 only if the numerator becomes equal to 0. So therefore I can say x minus 4 should become equal to 0, right? That means you can simply say that x will become equal to 4. So x equal to 4 is the x coordinate of point A. So I can now say that point A will have what coordinates? So x coordinate is 4 and y coordinate is 0. So I can write here for point A, the x coordinate is 4 and the y coordinate is 0. Right, guys? So first part is solved. We have got the x coordinate of point A. Now I want to find the equation of the tangent which is drawn to the curve at point A. So again, I come to point A, and if I draw a tangent at this point A, so let's draw a tangent at point A. So maybe I can draw a line which is like this. So this line is a tangent to the curve, right? I can call this line as a tangent to the curve. See, this line is a tangent to the curve, isn't it? So if this line is a tangent to the curve, this is a tangent to the curve. I want to find its equation. So tangent is nothing but what? Just now we have discussed in the previous questions that a tangent is nothing but what? It's a line. So to get the equation of a line, we have the form which is called as a slope point form. We can make use of the slope point form to get the equation of the line, isn't it? For that, I need the slope and I need one point on the line. So point is known to me, and that is point A, whose coordinates is 4, 0. What is more needed is the slope of the line, or I can say the gradient of the line, right, guys? Isn't it? So if I want to get the slope of this line, I should be differentiating the equation of the curve. Don't you recall what is dy upon dx, students? When you say dy upon dx, this is nothing but the slope, or we say the gradient, right? Slope, or you can call it as the gradient of the tangent, to the curve, right? Gradient of the tangent to the curve. So I know that if I differentiate the equation of the curve, so this is your curve, and its equation is y is equal to 9 times of x raised to minus 1 upon 2 minus 4 x raised to minus 3 upon 2. So if you differentiate this equation of the curve, you will get the slope of the tangent that is drawn to the curve. Now this tangent can be drawn at any particular point that you want. You want the slope of the tangent at point A. Then once you get dy by dx, you plug the coordinates of point A into that dy by dx. Students, very simple. So if you have the equation of the curve, you differentiate the equation of the curve, you get dy upon dx. Dy upon dx is the slope of any tangent drawn to the curve. The curve has infinite number of points. At every single point, you can draw a tangent. So every tangent will have the same slope, dy upon dx. What changes is the value. How it will change? Every point will have certain coordinates. You substitute, you plug the values of those point, the coordinates, into dy by dx. That will keep on giving different values of the slope. So I now am interested in getting dy by dx. So as I've said, what is y given to us? So y is 9x raised to minus half, 9 times of x raised to minus half minus 4 times of x raised to minus 3 upon 2. And what are the coordinates of point A? So A has coordinates 4, 0. So let's get dy by dx, students. Let's get dy by dx. So I'll write differentiate both sides with respect to x. So I get dy upon dx is equal to, so 9 is a constant, right? So keep 9 outside the bracket. X raised to n. What is the derivative? What is the derivative of x raised to n, students? Isn't it n times of x raised to n minus 1? The derivative of x raised to n is n times of x raised to n minus 1. So x raised to minus half will have minus 1 upon 2, x raised to minus 1 upon 2 minus 1. So minus 1 upon 2 minus 1 is minus 3 upon 2. Minus 4 times of x raised to minus 3 upon 2 is, again, it's like x raised to n. So minus 3 upon 2, x raised to minus 3 upon 2 minus 1. So that gives you minus 5 upon 2 and bracket close. So that's the derivative. So you want to simplify this derivative a bit further, isn't it? So I can write this is equal to 9 times of, so look at the second term. The second term is minus 4 multiplied with minus 3 upon 2. You can easily understand that the negative multiplied with negative will become positive. The 4 and the 2 will cancel, right, guys? So the 4 and the 2 will cancel. You get this 2 over here. So that's minus 2 multiplied with minus 3. That should give me plus 6. So I'm going to write 6 divided by x raised to 5 upon 2, right? So x raised to minus 5 upon 2 is like x raised to minus m. X raised to minus m becomes 1 upon x raised to m. So x raised to 5 upon 2. And then the next term is going to be what? The next term is going to be minus of, you have 1 upon 2 x raised to minus 3 by 2. So that's 1 upon 2 x raised to 3 by 2. And you can close the bracket. So that's your dy by dx. Again, students, what you can do is you can take out a few things common from there. You can take out x raised to 3 upon 2 outside the bracket, right? So I can have this is 9 bracket 6 upon x raised to 5 upon 2. X raised to 5 upon 2. Is it not x square into root x? Right, guys? Root x is what? X raised to half. X square into x raised to half. So that's 2 plus 1 upon 2. A raised to m into a raised to n is a raised to m plus n. So that gives me x raised to 5 upon 2. So x raised to 5 upon 2 is basically x square root x. So I can write here x square root x minus 1 upon 2. X raised to 3 upon 2, already explained to you, it's going to be x root x. X root x. So can you from here take out x root x common? Right, students, I can take out x root x common. So 9 upon x root x is taken out common. So what's left? So x root x is taken out common. You're left with 6 upon x minus x root x is common. You get 1 upon 2, right? So you can cross multiply again. So if I cross multiply, I get 9 upon x root x multiplied with, you have 12 minus x divided by 2x. So finally my answer is 9 times of 12 minus x whole divided by 2 times of x square root x. That's my dy upon dx. So I've got dy upon dx, students. Dy upon dx is the slope, right? Dy upon dx is what? It is the slope of the tangent. So I can say, therefore, slope of tangent is 9 times of 12 minus x divided by 2 times of x square root x. So what will be the slope of the tangent which is drawn at point A? So therefore I can say, therefore, slope of tangent at point A, whose coordinates are 4, 0. That's dy by dx at point A. So it is 9, 12 minus x is 4 divided by 2 times of x is 4 root of 4. So 12 minus 4 is what? 12 minus 4 is 8. So that's 9 times of 8 divided by 2 times of 4 square is 16, right? 4 square is 16 multiplied root of 4. That's 2. So what do you get from here, the slope as? So I can easily see that the 8 and the 16 can cancel. You get a 2 here. So that's 9 upon 8. So the slope came out to be 9 upon 8. So I have got the slope of the tangent which is drawn at point A. So can I now get the equation of the tangent? So the space is exhausted over here. So I'm going to utilize the additional page. Okay, I'm going to use the additional page. So I know to find the equation of the tangent, which is a line, I'm going to make use of slope point form. So which question are we solving here? So we are solving question number 11, right? Question number 11, part B. So clearly mention what part you are solving here. So question number 11, part B is what we are solving. So I'm going to get the equation of the tangent. So equation of tangent at point A by slope point form. By the slope point form. So it is given by y minus y1 is equal to m multiplied with x minus x1. That's the slope point form. Now the tangent is drawn at point A. Point A has what coordinates? Coordinates are 4, 0. So that's your x1 and that's your y1. And what's the slope? M. M is dy upon dx. Dy upon dx at point A. And if you recall, it was 9 upon 4, right? It was 9 upon 4. Look at this. It was not 9 upon 4. Sorry. Very sorry for that. It's 9 upon 8. Good that we checked it in time. So it's 9 upon 8. So I write here 9 upon 8. So slope of the tangent is 9 upon 8. So I can have now y minus y1 is how much? Y1 is 0. What's the slope? It's 9 upon 8 multiplied with x minus. What's the value of x1? So x1 is 4, right? So if you want, you can simplify it as 8y is equal to 9x minus 36, or I better write it as 9x minus 8y is equal to 36. So you can keep your answer at this particular place. Y is equal to 9 upon 8 times of x minus 4. So it looks like y equal to mx plus c. So for that, you want to multiply that 9 upon 8 inside the bracket. So that gives you y is equal to 9 upon 8x minus, so 9 upon 8 multiplies with 4. So 4 and 8 cancels, you get 2. So minus 9 upon 2. So you could keep your answer here. That's one of your answers. Okay, that's one of the form of the answer. Or you can keep your answer in this form. Both the answers should fetch you full marks. So that's question 11b. Okay, guys, now let's go to 11c. So here you want to find the x coordinate of the maximum point of the curve. So maximum point of the curve, look at this. This is the graph, right? This is the graph. This is the diagram of the curve. So there is some maximum point of the curve. So the maximum point, wherever it is, we remember that for the maximum or the minimum point on the curve, the dy upon dx, the first order derivative, should become equal to 0, right, students? So for maximum or minimum point on the curve, dy upon dx should become equal to 0. So for maximum point, you can say dy upon dx should become equal to 0. Don't we have dy upon dx? Students, we have already got dy upon dx, right? So dy upon dx, if you recall, was this, isn't it? 9 times 12 minus x divided by 2 times of x square root of x. That's dy upon dx. That needs to be equal to 0. So we know dy upon dx is equal to 9 times of 12 minus x whole divided by 2 times of x square root of x. So this needs to be equated with 0. So I can write here 9 times of 12 minus x divided by 2 x square root x should become equal to 0. Now again, I know that a fraction can give us answer 0 when its numerator should become equal to 0. That means 9 times of 12 minus x should become equal to 0. That simply gives me x should become equal to 12. So when x is 12, students, when x becomes equal to 12, at that time I can say that the function will have a maximum value, right? So I can have like this. Therefore, at x equal to 12, function attains its maximum value. If you want to get what that maximum value is, you plug the value of x equal to 12 in the equation of the curve, the graph that you have. You plug the value of x as 12 in the equation of the curve. That will give you the highest value, the maximum value the function could attain. That will be the value of y, right? And now for the last part, students, find the area of the region which is bounded by the curve, the x-axis and the line x equal to 9. So I again go back to the graph. Okay, so I now definitely know that at this vertical line, this is the vertical line whose equation can be called as x equal to 4, right? This is x equal to 4, isn't it? So I'll just draw a very proper line. This is the line x equal to 4, right? And then there will be another line which is x equal to 9, maybe let's say at this particular place. Okay, so just a random diagram that I've drawn. Okay, so you want to find the area of the region which is bounded by the curve. So the curve has to be there, then the x-axis and the line x equal to 9. So I can have this line is x equal to 4 over here. So I'm going to write the equation of this line as x equal to 4 and this line is x equal to 9. So I want to find the area that is bounded by the curve, the x-axis and the line x equal to 9. So am I interested to get this particular area. So I'm going to shade it. Okay, students, I'm going to shade the region which I want to find the area for. Is this the region whose area I want to find? Right? This is the region whose area I want to find. So students, what is integration basically? So integration is basically the area under the curve up to the x-axis, right? Integration is nothing but what? It is the area under the curve up to the x-axis, isn't it? So I'm going to get the area under the curve up to the x-axis. So I'll shade it again very quickly. Let's shade it again. So I want to find this particular area. Okay, this is the area that I want to find. So that's, this region is the area enclosed by the curve, the x-axis, and the line x equal to 9. So we know that this line was x equal to 9 and the line x equal to 9. So I want to get this area, right? So this is integration, right? So you want to simply integrate. So I can say integrate. And what are the vertical boundaries? The vertical boundaries are x equal to 4 to x equal to 9. So area of the region bounded, area of the region bounded by the curve, the x-axis and the line will become integration of. So the limits are from where to where? The limits are from x equal to 4 to x equal to 9. X equal to 4 to x equal to 9, right? And what you want to integrate? You want to integrate the equation of the curve. So what was the equation of the curve that we had? Equation of the curve was 9 times of x raised to minus half, 9 times of x raised to minus half minus 4 x raised to minus 3 upon 2 dx. Let's check it one more time. 9 times of x raised to minus half minus 4 x raised to minus 3 upon 2. So area under the curve will simply be now given by the integration of the equation of the curve within the given limits, right? So 9 is a constant for the overall integration. It goes out. What is integration of x raised to n dx? Do you remember what is integration of x raised to n? It is x raised to n plus 1 divided by n plus 1. So I can have 9 inside a bracket, x raised to minus half. So like x raised to n plus 1, x raised to minus half plus 1. That gives me x raised to half divided by 1 upon 2, right? X raised to n plus 1 upon n plus 1. Then a minus 4, x raised to again minus 3 upon 2 plus 1. So minus 3 upon 2 plus 1 will give you minus 1 upon 2. Is that right? Isn't it? X raised to minus 3 upon 2 plus 1. So minus 3 upon 2 plus 1 will become minus 1 upon 2 whole divided by n, which is n plus 1, which is minus 1 upon 2. And the limits are from where to where? The limits are from x equal to 4 to x equal to 9. Right, guys? X equal to 4 to x equal to 9. So I have limits from x equal to 4 to x equal to 9. Okay. So now what you need to do is a bit simplification is needed. So I can write this is equal to 9 times of 2 x raised to half can be written as root of x, right? Then the negative sign here and this negative sign will become positive. 4 upon 1 upon 2, that gives you 8. X raised to minus 1 upon 2 becomes 8 upon root x. The values of x are from 4 to 9. So you want to plug the upper limit first and then the lower limit. You can all do all these things on the calculator as well, but I would strongly recommend to write the steps. So 9 times of 2 upper limit, I'm going to substitute the upper limit, students. Root of x is 9 plus 8 upon root of x is 9. So that's the upper limit minus 2 times of root of x is 4 plus 8 upon root of 4. That's the lower limit. So that should give you 9 times of 2. Root of 9 is 3. 2 times of 3, that's 6 plus 8 upon root of 9 is 3. So 8 upon 3. Then minus root of 4 is 2. 2 times of 2. So that's minus 4 plus 8 upon root of 4. That's 8 upon 2. 8 upon 2 is plus 4 again. So 4 plus 4 is simply going to become 8. So I'll directly write it as minus 8. Right, guys? So that's minus 8. Close the bracket. 6 minus 8 is going to be 6 minus 8 is going to be minus 2. So you have 8 upon 3. 8 upon 3, 6 minus 8 is minus 2. Let's simplify it further. So 9 times of 8 minus 3 to the 6. So 8 minus 6. 8 minus 6 is 2 upon 3. So the 3 and the 9 will cancel. Right, guys? 3 and the 9 will cancel, get 3. So the answer is 6. Since this is the area, you can, if you want, write the units as square units. This is the area under the curve. So this is how the last part of the question is solved. So that will fetch you another 4 marks. The previous part C has fetched you 2 marks. The previous one has fetched you 4 marks, and the previous one has again fetched you 2 marks. So you can observe that this question has come for a whooping 12 marks, right, guys? So that's how we end our question paper. I hope, students, you have understood the entire question paper, all the questions from it which I've discussed very thoroughly, right? I'm going to post the PDF of this entire solution into the description box. You can anytime go there and take a look at the entire PDF, the entire solution of all the questions. And students, if this video has made any change in your life, if you think that it was worth enough, then please make sure that you share this video, you like this video, and subscribe to my channel. Students, thank you so much for joining in. We'll meet for the next time with a new question paper. By that time, you'll all have a great day ahead.